All right, let me set the context for the video. It's a 3 hour stream where I'm trying to build bolt.new, but for mobile applications. So a website where you can come prompt a mobile application to be made. AI will generate that website and you have a VS Code like UI on the front end through which you can either edit files yourself or ask the chat GPT or whatever LLM you are using to create follow-up prompts and create a React native based mobile application. You can test that on your mobile, or if you want, you can test that, on the web as well. Bunch of interesting challenges here. Some of them I wasn't able to get to, so I'll see you on GitHub in case you want to, contribute to those. But long story short, the things to learn are React Native Expo router, how does it work, and what is one of many ways to create a mobile application. Number two, again, talking to LLMs, fairly simple stuff. A very nice architecture that is used in multiplayer games and problems like these, Replit, all of them require like a very certain worker architecture that we've tried to build. Again, we weren't able to reach that part. That's still pending, but the architecture is discussed and some pointers are given in case you want to build it yourself. It's a much leaner, simpler approach compared to like a heavy Kubernetes based approach. It's fairly simple. So understanding that, what else are we learning in this video? A bunch of prompting, what all challenges come, how do AIs hallucinate, and also like parsing responses from AI. Like it's very easy to talk to an AI if you're talking to it as a human, but if you want AI to do something, if you want AI to generate a few files, run a few commands, create a React Native application, it gets tricky. That's probably the most tricky bit here. But if you ever want to build agents, for example, what is an agent? An LLM telling you to do something, send a WhatsApp message, Telegram message, I don't know, respond to a customer support query. Very similar sort of prompting is used over there. So that's the only new thing you learn here, something that was probably introduced a year ago. How do you write sophisticated prompts? How do you parse responses from an LLM to do tasks like creating files and running commands? Prerequisites. Next.js is good, even though the front end is front end. If you don't want to build the front end, want to build it in React, that's fine. Backend, maybe we've used Bun, so if you know Node.js, you'll be fine. Auto scaling groups in AWS aren't a prerequisite because we did not build a certain portion, but if you want to build that, it'll be good for you to know what are ASGs. We covered this in the cohort last week. One of the motivations for the video was it'll be a good practical video for people who covered ASGs last week. In the cohort, LLM APIs, what are LLMs, what is a system prompt, having some credits, unfortunately, in either OpenAI or Claude. If you want to do it for free, you can use Gemini. But Gemini did not respond really well for this. I had to delay the video because I did not have credits either, and took a day for me to put in credits. And that's it. There are no other prerequisites. I've cut it short. Whenever I'm writing front ends, I fast forward it just to focus on the interesting bits. So hopefully it's an interesting video. Let me know if you like it or not. With that, let's get into it. Also, a quick call out. If you want to participate in Super 30 or get in the next one for free, these repositories are good to contribute to. A good proof of work includes either you've gotten into GSOC, either you have contributed to one of our repositories, or if you're really good in Web3, specifically Solana. So if you have proof of work in any one of three of these, it'll be a good path to get scholarship in the next Super 30, like 100% scholarship. So maybe that's motivation for you to contribute. Cool. I'll see you in the video. Alrighty. Building a website that lets other people build mobile applications using AI. Bolt has been the first company to do this. It's a little hard to do. I'll share why. But long story short, all companies that are in this, website that lets you make websites, Webflow, Bolt, Lovable, Framer, will slowly get into this market, and they've been the first ones to do it. If you now go to bolt.new and type out, I want to build a mobile application that is a chess playing game, let's say, it'll build a React native application for you. All the code will be written directly inside the browser, and of course it's a mobile application, so you can test it. It's written in React Native, which means the code will be in TypeScript, but eventually it'll run on any native device. Let's look at a very quick demo and let's understand what are the challenges in building something like this. Why is it so hard? Why is no other company yet in this market? If you look at any AI product, for example Devin, it doesn't work really well with mobile applications right now. The answer is, of course, it's very hard to debug the simulator. It's very hard to open a simulator inside a website, which is why AI can get a little janky when going through mobile application code. So we'll understand how to build something like this. By the end of it, we'll have a similar website where people can come, they can give a prompt, and they'll see a very similar UI where their code is being written on the right. And by the end of it, they have a mobile application that they can see on the browser as well as test on their device. Let's wait for it to finish and let's quickly see a demo of what they've built. All right, AI hallucinated as expected. So the first version that I tried to build did not work. Here is the second version, which is something I tried to build yesterday. The final application that it spit out looks very close to a chess game. And this is React Native code, which means it'll run natively on any device. You can test it directly in the browser. React Native lets you spit out websites as well. But eventually the goal would be to preview this on a device. So if you click on device preview, it gives you an Expo QR code. Now we'll understand what Expo is. What does it mean to use React Native with Expo or without Expo? And how can you test this locally on your machine? What makes all of this sort of possible? But right now I have the Expo app open on my phone. Let me show it to you. This is what the Expo app looks like. I can scan this QR code, and now this application will start to bundle on my machine or my phone, and then I can start to run it natively. I can test it. If I think everything is good, then I can go back to bolt.new, publish the application from here, or export the application locally and publish it independently. That really depends on me. Let's wait for this to finish, and let's try out a quick demo in our mobile device as well. Then we'll get right into it. There we go. I have the chess game on my phone as a mobile application. I can play it over here. In fact, I see better colors here compared to the browser version. If you see right now, if I select a piece, you guys can't see it, but there's like good color coding right below it. And what's even better is I can actually change the code over here. If I go to the code and try to change something, let's say, I don't know, go to chessboard.tsx and add something random over here. Let me add some text. And save it. The best part is it reloads in my machine, which in this case, of course, it doesn't work because I probably forgot to import the text component is my guess. Let's look at the error. Yep, text does not exist. So let me quickly import text from React Native. Save it. And now my phone reloads again. And if you can see, there's hi there written all over the chessboard. You guys can't see, can you? Probably can, right? So what is the other good benefit of this? I can write the code in a browser. I can test this on my machine, all happening, in real time. I don't have to rebuild the application or anything, which is great. A great way to ship MVPs. At some point, AI will hallucinate. At some point, as this project grows, you can't do this on a website. You have to move it locally, then maybe use Cursor to do it. And then after that, again, at some point, Cursor will not be able to do it. You have to do it manually. So all of those things still apply. But our goal and, the biggest PMF of these companies has been in shipping out MVPs. If you want to ship out a quick, minimal viable product, now you can do that for mobile applications as well, and not just websites. So hopefully you understand what we're building. We're trying to build a website like this, where this is the prompt that I gave. Build a mobile application that plays chess. This is the code that the AI spit out. I can look at the code directly in my browser. I can edit it if I want. And I can preview the application here. Let me open this in a new tab. It still has the error from before. But if I open this in a new tab, it also exported a website for me where you see hi there everywhere, which is the text that I added. And along with that, I can eventually export this as an APK and publish it to the App Store, Play Store, and have a real functioning mobile application out in the real world. With that, let's get into the architecture of building this. It's a little tricky. We'll have to understand a little bit about React Native, its architecture. Then we'll have to understand what makes this possible. How do you connect the browser? The architecture is a little ingenious. If you've seen my Replit video, the architecture will be fairly simpler or similar, but we'll choose a simpler route. The Replit video was a little hard for people, which is what the comments said. So we'll not over-engineer this. We'll keep a simpler version. And if you want, I can eventually talk about the Replit architecture as well, but we'll have a simpler architecture, much easy to digest. Even if you're a beginner, you don't know a lot of DevOps, you should be able to follow along and try to finish this application by the end of it. ठीक है जी. With that, let's get into the architecture of building something like this. That will include a little bit about the architecture of React Native and then the architecture of the final application that we're building. All right, let's understand the architecture of building this. Before that, let's understand a little bit about the React Native architecture, because a lot of this is made possible because of the way React Native works. if you've ever written React Native code in the past, what you're actually writing is a bunch of, TSX files or JSX files, a bunch of not React components, but, React Native components, which basically means you don't write div. You write something like view, and you don't write span or h1. You write something like text, inside which, you write hi there or whatever you want, slash text, slash view. This is a very intuitive model to people who have already written React, which is why this is one of the benefits of using React Native. A JavaScript developer, a React developer can easily make React Native applications, or more technically, native applications that run inside a mobile device. The way it works is eventually all of these get bundled into a single JavaScript file, let's say called bundle.js, or a bunch of files, using something called the Metro bundler. Think of this similar to Webpack or any other, bundling technology in JavaScript or TypeScript or React. In case of React, a lot of times you use Webpack to bundle your code finally into HTML, CSS, and JS. And similarly, in case of React Native, you use something called the Metro bundler to spit out a bunch of JavaScript files. The reason this is cool is because this JavaScript file is all that is needed to run your final mobile application. Your mobile application's state, any application logic, what happens when you click on a button, what needs to get printed on the screen, is defined by this bundle.js file. So serving a React Native application is actually as simple as serving a simple bundle.js, which is what makes this a unique and easier challenge compared to bundling and distributing, let's say, a Swift application or a Java Kotlin application. Is that we're already very familiar with serving HTML, CSS, and JavaScript files, and this is something very similar. You have a bundle.js that you need to serve to the user. They will start to see the application on their mobile device. Of course, they require a bunch of other native code over here. In fact, there is something running on this native side that is talking to this JavaScript bundle, and the JavaScript bundle is responding back, and that is how your final application logic is running. Your final application logic is written in JavaScript, but this view that I've written over here eventually translates to something else, whatever is the way to render a div or a view in an Android app or a iOS app. But the logic, what happens when you click on a button, what happens if you swipe a screen, all of that logic is written over here. So in the end, a React Native application is some native code or like a native thread that is talking to some JavaScript code, bundle.js, which is dictating the native layer what to do. It is telling the native layer, please create a view, or please create a text, or please create an image. It is dictating this to the native layer, and the native layer is rendering those things in place. So that is a high level of how a React Native application generally works. This bundle.js, when you eventually publish your APK also, this JavaScript bundle is present over there. And on the final user device, this JavaScript code actually runs, and this sort of is the master brains behind all the things that are happening in your application. The reason this is cool is because the application that we're building today, which is bolt.new/mobile, let's say, whenever the user comes here, we can create a bunch of code for them. We can ask AI to write, whatever, to-do.tsx file, main.tsx file, so on and so forth. All of this is written by AI. But the good thing is, whenever we can compile this code, either in the browser or somewhere in the server, we'll do it in the server, but you can actually compile this in the browser as well and spit out a bundle.js. And that bundle.js we can serve somewhere on the internet. And then on my mobile device, I can test this bundle.js. So the reason this works so easily compared to Swift is because the architecture hasn't changed too much between building Bolt for websites and building Bolt for mobile applications. The only thing that has changed is we are now serving this JavaScript file compared to, in case of websites, we have to serve HTML, CSS, and JavaScript, all three of these files. The architecture in the end is going to look something like this. We have, let me just first take it through the flow. We have a website, bolt.new, and whenever the user comes here and gives a prompt, okay, I want to create a chess application, we're going to hit a backend. I'm going to call this my primary backend. The user is going to hit this backend, and we're going to talk to an LLM. We're going to enrich their prompt. They've just sent us chess. We of course need to tell the LLM, okay, you are an assistant, you are great at building mobile applications. This is the structure you have to give us the mobile application in. We have to enrich this prompt a lot. And in the end, add the user prompt, which is chess. Okay, this is what you're supposed to build, a very long prompt, along with what the user actually wants to build, which is chess. We're going to get a response back from these guys. And here is where, things get tricky. Okay, where do we store these files? Because we want in the end, okay, whenever the user is over here, they're able to see all of the code that the AI has written. They'll move to the next screen, right? As soon as they type chess over here, they'll move to the next screen where they need to see all the code on the right. That's what happens in Bolt, right? If I open bolt.new right now and show you, the user can actually see all of the code over here and of course preview it. So somehow that code needs to come to the browser. And then of course it needs to, eventually get exported and shown everywhere else as well. So this is a high level of what needs to be done, slash, what the user flow would look like in the end. The question is, how does this work? And this involves a very complicated architecture. So let's get into that next. All right, let's get into the architecture of building something like this. It's a slightly complex architecture, but one you can use for various types of applications. So let's discuss that in detail. We'll have a primary front end. We'll write it in Next.js, React we will see. And the job of the front end is to just render the sign up page, sign in page, the main prompt page where the user comes and shows the prompt. Whenever they're signing up, signing in, seeing their old projects, they're going to interact with what I'm calling a primary backend. A simple backend service that does authentication, lets them retrieve their old projects ka title and everything. And maybe one that also accepts the request to start a new arena. I'm introducing a new term here called arena. When I say arena, I mean this page, the page where you have VS Code open inside the browser, you have a terminal open over here, you have chat on the left. I'm calling this page the arena. So take that as a jargon from this point on. Until you open the arena, you are interacting with the primary backend. Independently scaled service, does nothing too expensive, simply interacts with the database, and that's it. The complicated bit comes after you enter the arena. After you tell the backend, hey, I want to create a chess application. This backend is not supposed to do anything. It is not supposed to interact with an LLM. It is not supposed to start to write your code. It is not supposed to create a VS Code remote session. None of that it will do. It is simply supposed to spin off a new machine, I repeat. And we'll change this architecture eventually and make it a little more cleaner. But abikle, it is simply supposed to spin off a new machine, which I'm calling the worker machine. As the user gives you the prompt, Iska job is simply spin up a worker machine and let the user know, hey, your worker machine URL is this 10-22/30.40, whatever. This is your worker server IP. Please talk to that machine. I am done. I am not going to interact with you any further. जो भी prompting करनी है, whatever talks you want to have it directly with the machine. And then you interact with this machine. Tell the machine, hey, I was trying to create chess. This machine is what interacts with the LLM, let's say Claude or ChatGPT, and generates your chess application. So on this machine, we have another HTTP service running. You interact with that HTTP service. Once you tell it, hey, I want to build a chess application, it talks to the LLM. The LLM tells it, hey, please create a file called whatever, chessboard.tsx. And you create this in the file system. It says create another file called, I don't know, whatever, board.tsx. So you create that in the file system. You start to enrich this file system based on what the LLM responded with. The user's front end is also connected to this machine via sort of a remote VS Code instance. You have some version of VS Code running over here, and whatever the user is seeing in the browser, that VS Code screen that they see on the right, this screen right here, this screen is actually a VS Code remote server that's running on this worker machine. You probably now understand why we needed an independent worker and why did I not make this primary backend do anything. The reason is because this worker has to do a lot of things. It needs to run VS Code remotely. It needs to talk to the LLM, which is an easy task. It needs to enrich the file system, put things in the file system. You don't want to do that for a bunch of users who are creating files. And it also needs to do one more thing, which is back all of this up to S3. So we will need another, I'm going to create another service here called, hold on, what's up with my pen? Oh, seems like it's just a bad pen. There you go. Another service called S3. It's not a service. S3 is like an object store. But the worker needs to keep backing up the code base, जो भी AI ने generate किया, over to S3 so that you have a backup of the user's code. You need to make sure as time goes by and the user is creating, a lot of things. They're all backed up to an object store. If they ever come back to the website, you need to show them their existing progress, whatever changes they made. So whatever, if I close this tab today and come back to it after 5 days, I should still see this project. This project needs to be persisted somewhere. And usually the place to persist a very big file system is something like S3, which is an object store. So that will be the high level architecture. Every user that is coming on your machine is going to have a dedicated worker that they are interacting with. Whenever they're running a command, changing something in VSCode over here, those changes are being persisted to the file system over here. This worker machine is dedicated for them. This isn't something new. This happens on Replit also. Okay, whenever you're on Replit, you have some guarantees of there is a 0.5 CPU, 2 GB RAM machine that you're currently working with, and that's dedicated for you through this session. Same is true for us. Whenever the user comes, we have some dedicated compute for them somewhere. And whatever they're doing is happening inside the blast radius of this worker. If they try to do something bad with us, they'll just kill their own server, which is fine. No other user is connected to the same worker. Every user has their own worker. You might be a little perplexed by this. Wow, Harkirat, if there are 1,000 people, we have 1,000 machines. So the answer is yes, and there are ways to make this better. But if you have 1,000 users, then you also have $20,000 a month of revenue because each one of them is paying you 20K. And these machines are not that big. They're 2 CPU, 4 GB RAM sort of machines. Let's say some $40 a month or $50 a month machines. ऐसा तो नहीं होगा कि if a user has bought your plan for $20, they have it up 24/7. They are not on your website 24/7. They're probably hitting it 1% during the day. In the month, they're probably hitting it for 3 days. So for 3 days, you can have dedicated compute for them, and it's fine. It's not, you still have margins left for yourself. This is an architecture to build applications like this. It's used in a bunch of other applications that I'll talk through. But yes, if you have 1,000 people currently on the Arena screen, I repeat, if you have 1,000 people currently on the Arena screen independently building their projects, then yes, you have 1,000 worker machines running. Each user is interacting with their own worker. They'll come to the Arena page. They let it know, hey, I want you to create ChatGPT. This will talk to the LLM. LLM will respond back with a bunch of files you have to create. You will create the files over here. You will back them up to S3. And you'll keep re-interacting with it. You might change some code over here in VS Code. That code will also change over here in the file system. That code will also get updated to S3. But as time goes by and you make a bunch of changes, eventually you're going to leave, right? You'll close the tab. I can currently go over here and close the tab of Bolt that I was on. When that happens, you need to downscale this machine. How do you do that? How do you know if the user has left? So here comes another slightly, a mildly jargony term called heart beating. What are we introducing here? Heart beating basically means that this machine will keep hitting its worker every 5 seconds. Hey, I'm still alive, I'm still alive, I'm still alive. And the worker will keep responding with, okay, thank you for letting me know. It's also called a ping pong. I'll send it a ping message. It'll just respond back with a pong message. And that lets the server know that there is someone who needs this machine. There is someone on the dashboard page. He's still interacting with VS Code over here. I should not kill myself. But if you don't receive a heartbeat for, let's say, 5 minutes or 10 minutes, if you're not receiving this ping message every 5 seconds for a span of 5 minutes, then this machine can safely assume that, hey, the user has probably left. They are no longer on their browser. So I can kill myself. So the machine will sort of, kill itself. How all of this happens is a very interesting, not architecture, just APIs that you have to call. But that's an interesting thing to learn here. Okay, how can machines self-destruct when they feel they're no longer needed? You could also extend this architecture. You might say, okay, Harkirat, multiple people could be editing the same project. Could totally happen, right? Okay, you add collaborative features to your Bolt thingy. 5 developers can come and start to edit the same code at the same time. In that case, all those 5 developers need to be connected to the same worker machine. So this is worker machine 1. If they're all on the same project, project 1, project 1, project 1, they all need to be connected to the same worker machine. If this guy leaves, that's fine. This worker machine still needs to be alive. This guy leaves, worker machine still needs to be alive. This guy leaves, then the worker machine should kill itself in 5 minutes because everyone in the room has left. So what are we, and okay, one more thing that I have to talk about now that I see the scanner on my screen. If you look at it, as soon as I started this project, the project ran npm run dev over here. The preview section showed a QR code. As I said a while back, this QR code is nothing but this URL where they're currently hosting my bundle that Expo needs to. If I pick up my phone, there you go. If I pick up my phone and scan this QR code, what is happening? I'm just going to this specific URL and downloading a JavaScript bundle. Our users will do the same thing. And when they do, they'll get the JavaScript bundle from the worker machine. So the QR code that you're going to see over here, and if this is my mobile device, when I'm scanning this QR code, I'm actually reaching this machine where we're exposing that bundle.js because you are connected to this machine via VSCode. You are running npm run expo on this machine. So this machine is what is exporting that bundle.js, and on your phone, when you're scanning bundle.js, you're getting it from here. On your phone, you're getting the mobile application that you can preview. Of course, on the front end also you can preview. We'll come to how that is. That's actually much easier. But this is the harder bit of, or the new thing that has happened. Okay, now on Bolt, you can actually scan a QR code and see the mobile application eventually here. Question is, how do you build this? How do you build a fleet of auto-scaling servers? What do we need? A fleet of auto-scaling servers, let's say oopsie daisy. Let's call it auto-scaling groups, shall we? A bunch of auto-scaling groups. How do you create them? How do you make sure if a new user comes to the arena screen, you assign them machine number 1, and new user comes, you assign them machine number 2. New user comes, machine number 3. New user comes, no, not enough machines. You spin up a new machine. New user comes, you spin up another machine. This person leaves, you kill this machine. How can you build an architecture like this? And this is useful in a lot of places. If you've ever played multiplayer games, then also same thing is happening. If there is a multiplayer game like Counter-Strike, 3 people are usually connected to the same backend server or real-time server. And whenever I move a bit over here, I send this change over here, everyone else in the room receives it. Same architecture. If you want to create a multiplayer game today, and let's say 3 people come to the same room, all 3 of them need a dedicated machine for themselves. If 2 people come to the next room, they need a dedicated machine for themselves. So how do you create an architecture like this? How do you make sure that if new users come and create new arenas or create new multiplayer games in this case, how can you get dedicated compute for them, let's say a machine, and connect everyone in the room to the same machine, everyone that's interested in that room to the same machine over here? Here comes a very first principles architecture, which you might think it's so dumb, but also one that I've used in a few companies that had cloud bills of 150K a month, which is which basically, and most of this was this architecture only. It works. It's an architecture that works. It works at scale, but it's just very first principles. It seems like it's so simple, and why is this it? But the answer indeed is this is it. The way it works is, if you remember, we had a front end and we had a primary backend. Whenever the user is initiating the request to go to the arena, right? Whenever the user is telling the primary backend, hey, give me a new machine, I want to go to the arena page. The primary backend needs to somehow be aware of all the machines that are currently up, all the workers that are currently up. And the primary backend needs to fetch one of these workers and let the user know, hey, this is the worker assigned to you. The primary backend also needs to store somewhere that this worker is no longer available. This worker is already assigned to this arena room. How can you do that? The answer, as I said, is by using a router architecture. What we can do is create another service. Service ka matlab kuch nahi, another backend called the router. Why is it called the router? Because it routes people to a specific worker. That is why it is called a router. And the job of the router is simple. The router needs to make sure we always have enough compute available. So if no one is on our website, the router needs to tell someone, the cloud provider, AWS, let's say, कि hey, 3 machines को ready रखना. Keep 3 machines ready. God knows when we get new users. So let's say our buffer count is 3. What is our buffer count? Or let's call it the warm pool count. it's 3. Warm pool count or buffer count means what? It means that even if we have 0 users, we have 3 machines always available because the user could join immediately. When they do, we need a machine for them available immediately. So let's say our warm pool count is 3. Then what happens is these 3 machines are up, and these 3 machines will tell the router, hey, router is, let's say, hosted on router.v0.100xdevs.com. They'll all keep heartbeating to the router. I repeat, they will all keep telling the router, hey, I am available. There is no one connected to me. So feel free to assign a user to me. Feel free to assign a room to me. Every 10 seconds, let's say, they are heartbeating to the router. The router is keeping a track of this. Currently, the router doesn't know immediately kinke URLs kya hai. The router can simply tell AWS कि 3 machines chala do. It can just tell AWS कि please start 3 machines. But whenever they start, we can add a startup script on these machines कि यार जब भी तुम start होती हो ना, start an HTTP server that is constantly telling the router I am up, I am up, I am available. So the router is receiving these requests and backing them up somewhere, storing them somewhere, which usually is stored in Redis. Where is it stored? You can store it in Postgres, no real change here honestly, but Redis is the service that we will use to store the heartbeats of machines. As these machines come up, they'll tell the router, okay, haan, we are up. The router will know, okay, I currently have 3 idle machines. I don't need to spin up more machines. As soon as the front end asks the primary backend, hey, can I please get a machine? Or honestly, the front end can directly ask the router as well. That's what we did. The front end, whenever they want to reach the arena screen for whatever reason, open an existing project or start a new project, they can simply ask the router. The router can be like, Acha, I have 3 idle machines. Let me assign you machine number, let's say Redis machine number 1. So I asked the router, hey, can you route me to a machine? Can you tell me which machine I should use? The router will be like, sure, use this machine for your new project. The router will also keep track of this in Redis. Here the machine 1 is now occupied. The machine 1 is no longer available for someone else to take because it's already taken by this specific room. Let's say the room ID is 123. What is the room ID? It is this, whatever you see in the URL here, that's the room ID of my bolt room, and we'll have similar room IDs. We're persisting this in Redis ki, this specific room ID is working on this specific worker. What are we really persisting in Redis? We're persisting the URL of this specific server or the domain name of this specific server. Okay, this is where you want to route the requests. This is where you want to route everyone from room 123. What that means is if a new person joins and says, hey router, I want to join room 123. The router will be like, हाँ, ये वाली machine ले लो. This machine is already available. That happens in Counter-Strike. If you're using Counter-Strike, if 2 people join the same room, then both of those people should be given the same server. Both of them should be talking to the same server and exchanging messages. So, if you want to build a multiplayer version of Bolt, this architecture will help there as well. The router will be smart enough to remember which room is assigned to which server. If another person tries to join the same room, it will let it know the same server's address. Then comes the easy bit. This was the routing part. And iske baad the person will keep interacting with the service. We just have to make sure this server pe jo bhi chal raha is, doing the right things. This server, whatever is running over here, it can handle requests from this front end. This guy can back up things to S3, talk to an LLM, so on and so forth. And eventually when the thing dies, whenever this front end is connecting to this guy and this guy dies, it'll stop heartbeating to the router. Or it can also let the router explicitly know, hey, sorry, I'm dying. I don't need, this person left, doesn't need me anymore. So I'm going to die. And the router can be like, sure, take my, idle count doesn't change at all because already this was occupied. It wasn't idle. So it'll just keep track of room 123 is no longer going over here. If a new person wants room 123, I'll give them a new server. So the router will keep track of this and just remove this specific machine from its ordering in Redis. This machine has now died. A bunch of interesting question comes here. Harkirat, what if I am connected to this machine and beach mein I die? What if while I was connected to this machine, something happens and this machine ends up dying? What will you do then? So the router should ideally be reassigning machines to you. And again, this happens if you're actually building a Counter-Strike game because you can't really refresh there. That's a big problem. In our application, it doesn't matter. We can just ask the user to refresh. So the router can just assign them a new machine. But ideally, the router should be connected to the user via WebSocket server. And the router, if it feels some machine has died, It should let the user know, hey, your old machine died, please connect to this new machine. And then of course this new machine should run the logic of startup of, getting things from S3 and getting the project set up for the user. So the router's job is what? The router's job is, one, keep a warm pool of machines ready. Keep talking to AWS every 2 minutes and keep telling AWS, hey, we need 3 machines. And if one of them gets occupied, keep telling AWS, sorry, we need 4 machines, so that AWS scales up. If this also gets occupied, then tell AWS, hey, we need 5 machines. This also got occupied. Always be a few steps ahead. Of course, it can happen that 3 people come to your website at the same time. And in that case, the router can't respond. The router unfortunately has to wait. The router will tell you on the front end, hey, sorry, too much traffic right now, you have to wait a little bit. So you keep waiting, you keep polling the router. Then eventually the router has told AWS will eventually start a machine, the router will assign this machine to you. But that's where you have to make a compromise. Okay, what should your warm pool count be? Should it be 3 or should it be 5 or should it be 100 based on, what kind of spikes you're expecting? If you're expecting ekdam se hi 10 log aa jayenge, if you're expecting immediately 10 people can come to your website, then have a warm pool of 10 always available. Usually it takes 30 to 40 seconds for a new machine to start. So if you're expecting, greater than 10 people to hit you in a span of 30 to 40 seconds, then make sure you have greater than 10 as the warm pool count. You always have 10 idle machines always available. Doesn't this look like an ugly architecture? It always does, but again, it works. As I said, I've used this in a bunch of companies. It's very first principles. Okay, if you don't know any fancy DevOps technology, you can still work with this because it just works. And it's been tested at scale. The worst thing you will see is, number one, slightly bigger cloud bills, because what will happen is, you have the warm pool of machines ready. That will happen in any architecture. You have to be over prepared for, if a spike comes or a traffic comes. If you're in the most ideal scenario of only one person coming in a span of 1 minute at max, then you can have a warm pool of one machine. That's no cost really there. But unfortunately, if you have a scale like Bolt, which I'm assuming they have, I don't know, some 10K paying users, no, probably more, whatever, then you have to have that compute ready. In the end, you will have margins left for yourself. Bolt is doing 10 mil ARR, probably making a mil a month or more. This isn't too much money for them to spend. And also, if compute price goes up, you can do 10 different things to optimize it. So the other reason it's a little expensive or slightly unoptimal is you'll probably wait for 5 minutes to cool down the machine or stop the machine or drain the machine if the user leaves. That's also 5 minutes of extra compute time that you're paying for, which is not really something in the long run. Cool. So we had the architecture. To recap, these are the things that we're going to build today. It will include a primary frontend in React. It will include a primary backend in Next.js. It will include a routing service that will talk directly to AWS through some APIs. We'll talk through what those APIs are. We'll have a primary database, let's say Postgres. We'll have Redis as our, Redis being the space where the router is going to keep track of every machine that is up. We'll have a fleet of AWS machines where we're running a lot of things. Like we're running VSCode over here. The user is connecting to this VSCode sort of instance, a remote VSCode instance, and editing things here. This guy is supposed to talk to an LLM. Sorry, 1 second. This guy is supposed to talk to an LLM. This guy is supposed to back things up to S3. And this guy is supposed to self-destruct, which basically means this guy will also talk to AWS, or it can go through the router. You can tell the router, hey, I think it's time you kill me, and then the router can kill. That's probably better. Let's not make this guy directly talk to AWS. Let's make this guy talk to the router and tell the router, hey, feel free to kill me. And then the router can tell AWS, okay, this is a machine that you can kill. And in case it needs to scale up, it can let AWS know to scale up as well. Decent architecture, pretty decent. I would urge you to build this yourself. I built a bunch of this in a company, and it's pretty beautiful if it works by the end of it. If you see machines scaling up and down, it just works. And when you see cloud builds, because you'll only build this architecture if you're building an application like this, very intensive on compute. Someone is coming to your website and literally needs a machine at the backend to do a bunch of tasks. So whenever you see websites like these or apps like these, you also see a bunch of cloud builds which are great to optimize when the time comes. If you're hitting 100K a month, which a company that I sort of work with does, you can do a lot of things to optimize it. It's a lot of fun to do that, but let's not go there. Abhi ke liye, let's focus on building. What will you build in the next section? Let's quickly hash out the primary backend. Let's quickly hash out authentication. We're going to use Clerk for authentication. And the backend will be most probably in bun. Let's quickly create a bunch of these endpoints, hash them out so that we can get into the interesting bits, the juicy bits, the router and the worker are going to be the juicy bits. The router having a bunch of logic to talk to AWS, a bunch of logic to talk to machines, and a bunch of endpoints exposed for the worker. The worker having 10 different things. This will be the most interesting challenge here. Front end will be fairly simple. We'll get to it towards the end. Abhi ke liye, I'm going to focus on the primary backend. Let's get into that in the next section. All right, let's initialize a fresh Turborepo. Let's call it Bolt mobile app. Let's select Bun as the runtime. Let's open the project in Visual Studio Code. Let's quickly create the database schema first. So I'm going to create a fresh package called DB. I'm going to go to the DB folder. I'm going to do a bun init. I am going to do a np or bun install Prisma to add Prisma as a dependency. Prisma is the ORM that we're using today. npx or bunx Prisma init to initialize an empty Prisma / schema.prisma. Let's quickly write the schema for today. I think we're going to have a table called users ID, which is a string, which is the primary key for the table, which defaults to UUID. Email, password, created ad, updated ad. I don't think we need the password. Everything else is fine. The second model is going to be, let's think about it. Project ID is the important one. Don't really need a name or description, but an optional description would be nice. This description is what shows up here amongst all the projects that you have. So the description of this project is chess game app setup. This one is dancing person mobile app, so on and so forth. That's all we need for the database schema, a model called projects and a model called users. Let's create a local database locally really quickly. I'm going to use Prisma for it, Docker for it. I already have Postgres running on that port, so let me close the old one that I have. Run it again. And now I have Postgres running locally. This is my password to Postgres. So what can I do? I can go to the .env file that exists in packages/db and replace this database URL with Postgres, this password, localhost at 5432, Postgres, and that's it. Let me migrate the database. I'm going to call the migration init. Let me generate a client, bunx Prisma. Great. And let me export an index.ts file. We probably already have one, db/index.ts, where I'm going to write import, there you go, Prisma client from Prisma client, export const Prisma client equal to new Prisma client. And I'm going to go to package.json here and add a new export. Is it exports or is it export? I'm unsure. Might be exports only. I cannot be wrong. /client as /index.ts. So the index.ts file hai, whatever we have over here, which is just a simple export of the Prisma client, is what we're exporting from this DB module. Is jo DB module hai, it is going to export at the /client subroute, whatever exists in this file, which is a simple export for now. Probably another thing we should introduce here is Redis. So let me do that because we'll eventually need it. So Redis Bun init. Bun add. Now the question is, I think it's Redis only. I could be wrong, but I think Redis is the Redis npm module lets you connect to Redis or create like a client to Redis. There's no concept of a schema here, so all I can do is import. We're not using IO Redis. Create client from Redis. Export const Redis client is create client process.env.redis client. Let me add a .env here where I'm defaulting this to localhost colon 6379, but that also means I need to have Redis running locally. So using Docker, I'm going to run Redis 6379 colon 6379. Think it is Redis. I could be wrong. Yeah, I think that's fine. Now I have both Postgres and Redis. Also, let me start in detached mode so it runs in the background. Now I have, if I run Docker PS, I have Redis running in the background. I have Postgres running in the background locally on my machine. And I'm exporting a Redis client from the Redis module, a Prisma client from the DB module. That's the two modules I've added. Maybe another one we need is AWS, but let's get there when we get there. Let's move on to creating the backend of our application. So I'm going to create a folder called primary backend, where we're going to write, the simple routes to get your projects, create a project. Yeah, these two are the only ones. We don't need sign-in endpoints because we're using Clerk for authentication, and maybe a middleware for decoding the user. So going back to apps/primary backend, I'm going to run bun init. In primary backend, I'm going to add DB as a dependency. So DB, I think for bun it's just star and not workspace star. And let me run a bun init globally. Sorry, bun install. And let's see if we can import Prisma client at the top. Import. Yeah, that looks fine. No red squigglies. Can I import the Redis over here? Not that we need Redis here. I'm just checking. Seems like we can, even though we didn't add it as a dependency, probably because it got rolled up to the top node modules folder at the top. So yeah, if you look at it, most probably Redis is a dependency here, which is why I did not have to add it, but it's always a good idea to add it to package.json. PQ. Oh God. Redis, there you go, which is a shortcut to our module. It exists in the root folder, which is why I was able to import it even though I did not add it to package.json. All right, let's add express as a dependency. So bun add express at types/express. Feel free to use whatever HTTP server you want. Let's set up express locally. Bun add course as a dependency. Maybe need to add at types/course as well. There we go. And now let's add our endpoints. We need one endpoint for creating a project. So app.post/project, which doesn't really need to get a name. This will be AI generated. So, it'll take the prompt as an input that the user provided us, the initial prompt, which probably is something I need to put in the database as well. So every project will have a bunch of prompts because, the user will give one prompt, the LLM will give a response, then the user will give another prompt. We'll keep chatting with the project. So we should update this to have a one-to-many relationship between the project and a prompt. Every project can have multiple prompts. So prompt, which is prompt array, and every prompt will belong to a project related through this project ID. This is all complicated. I covered a bunch of this in a few videos before. What exactly am I doing here? But this is just me defining my schema and a one-to-many relationship between projects and prompts. Every project can have multiple prompts. Every prompt is associated to a single project using this project ID field as a foreign key. Let's re-migrate the database. Let's go back here. The user will give us a prompt, but honestly, we don't need it right now. The HTTP layer will not start executing anything. This needs to go, the prompt needs to go again to the worker layer. So let's not worry about this yet. We're just going to create a simple project. The name, well, I guess we can get add logic to get a useful name for the project from the prompt. I've not done that right now, so I'm just going to hard code it. I'm just going to take the very first line as the description of the project, and this is not even name. I think in the database it was called, what is it called? Description. So I'm going to name this description, and description is what goes into the database. That's all we need. This much is enough to put an entry in the database and maybe get back a project ID, which is what we return to the user. Project ID, project.id. Iske baad, the user will hit the worker service and figure things out. All right, we'll create the router separately that will let the user find their worker. So that logic doesn't need to reside here. I think this endpoint is foolproof. The only thing is there is a to do here, which we'll fix eventually when we hit an LLM API. That's the project endpoint. Of course, there's a get projects endpoint, which honestly, yeah, let's not worry about individual projects. We don't need this. HTTP server doesn't need to return any of that. It's just all of your projects. So one more thing that needs to happen in the schema now is every user will have a bunch of projects. That means every project will have a user ID field. Ideally, it should be a relationship. I'm not defining it as a relationship for now for a few reasons. Because we're using Clerk, it'll get a little tricky if I restrict this to be a foreign key relationship, because if you're using Clerk, your users don't immediately reside in your database. वो Clerk के database में होते हैं. Eventually, you sync your database to their database. So what that'll do is if a user comes, signs up and immediately creates a project, we might not have that user in our database just yet when they're creating a project. So if I force this constraint, it'll be a problem. I'm not doing that. That's why. Cool. Project is done. User is done. Let's re-migrate the database. npx prisma migrate dev. I'm going to call this. What did we change here? We added user project relation. Now let's go back. And यहाँ पे we can say where user ID is, user ID equal to rec.user ID, which also means this should be an authenticated endpoint. So should this one, const user ID equal to rec.user ID, and we need to add user ID here. You'll see a type error here. We'll fix this very soon. But both of these are authenticated endpoints, which means both of these first need to go through a middleware. So let me create that. Let me create a file called middleware.ts, export function auth middleware. We'll get an authorization header from the user. Assume it's of this format, bearer space token. So what we'll say is, if not token, return 401. I need to add these imports in express, and next function also comes from express. And if the token is fine, firstly I need to add a dependency one add JSON web token, import JWT from JSON web token. And now, as the AI will tell us very soon, what do I have to do? Const decoded equal to JWT.verify, JWT not secret, a JWT public key. The thing is, we're using Clerk for authentication, and Clerk may you can export a public key. It's very scary to export a private key from Clerk, because if everyone gets that, or if it gets leaked, you're screwed. But Clerk, let me open the Clerk dashboard and show you what I mean. Whenever you're using Clerk for authentication, which means they'll own the sign up page, the sign in page, they'll give you some secret keys, some private keys. One more thing that they give you that makes your life a little bit easier, agar aap backend, if you want to use Clerk as the authentication provider but have your own backend, is they let you export public keys. So if I go to my project, for example, I'm using Clerk for photoai.com, photo.analytics.com. So if you go to this website and authenticate/sign up, all of your signups are actually handled by Clerk. And the way it's done in that project also is that when you go to the API key section, you can actually export this public key, and that public key is enough for you to decode your JWT. If you look at the code of Photo AI as well, you'll see in apps/backend/ is there a middleware here? There you go, middleware.ts. We can actually copy it from here. We get the token. If the token is not right, we return. We get the Clerk public key from an environment variable. And if you look at the decoded section, we do a jwt.verify, give the user's token. This is the formatted public key that we got from Clerk, which is this public key right here. And then we give it the algorithm, which I think by default is this only, RSA256. I don't know if you need issuer. These are fields I did not add. I think Yash added them. We'll figure out why, if they're needed or not. And this decoded will provide you with the user's user ID here. Decoded.payload.sub is what will contain the user's user ID. So if you're using Clerk for authentication, what will end up happening eventually is you have your front end, and when the user signs up or signs in, on your website, they'll directly go to Clerk. They will never hit you. They'll never hit your backend. You don't need a sign up endpoint. They will hit Clerk. They will get back a token. They won't immediately get back a token. They can issue a JWT or a token, and using that token, they can call your backend and send the token as a header. In the auth header, they can send this token, and on your backend, the key that you got from Clerk is what you can use to verify that this is indeed a message signed by Clerk. This user is indeed a person who has authenticated on our Clerk instance. This being my Photo AI Clerk instance, but I can create another application. We'll do that very soon, which will be called whatever, Bolt. And I'll take the key from here, put it in my backend, and my backend will now be able to authenticate users that have signed in via Clerk. What that means is they did not even have to sign up with me. I did not have to issue a token for them. Clerk will do all of that. I will simply decode their key and understand that this is this person, this is this person. And the format that Clerk returns it in is this. So we can also log this and see later on, but since we already have it, decoded.payload.sub is how you get back the user's ID. So if I have in my Clerk dashboard a user, if you look at all the users that we have, every user has a Clerk generated user ID. For example, this user here, there's no easy way to click on them. Users, this user right here has this user ID, and I get access to this user ID over here by, in this specific field. It's encoded in their JWT as .payload.sub. So their JWT payload looks something like this, payload sub and then their ID. So we get the user ID. We set that as, on this global request object. This is standard Express stuff if you've already done it. So I'm not taking you through it again, but this request object is what you override if you're ever using middlewares, which is what we are doing. We are going to very soon introduce a middleware here, and here we're accessing rec.user ID. Here we'll be setting rec.user ID, which is exactly what's done over here. So user ID is this. Let's add another check. If not user ID, then also return 401. And of course, other than that, rec.user ID is user ID. One thing you need to do here is add a types like a declaration file. Declare namespace express interface request user ID string. What this does is it makes sure that the request object hai express ka, which is this guy right here, this request object can actually be overridden. Its types are overridden now. It has a user ID field. So I don't see a red squiggly over here because I've added user ID as I would add it as a optional string because we might have it in some cases, might not have it in some cases. Request object by default doesn't have a user ID field. But you can enrich it with the user ID field now, and TypeScript won't complain because we've added this declaration file. Cool. So this is what the middleware finally looks like. Feel free to breathe it in. Let me do a bun add JSON web token. I think I already did that. I probably need to add its types. And the red squiggle goes away. There are a few things you can do here. Like Google what this exclamation is. There was a red squiggly over here which said, okay, we expect a string, but this could be a string or undefined. So I added an exclamation here, which means I know what I'm doing. I'm telling TypeScript. I know what I'm doing. This will always exist. That also means I should be responsible and add a JWT public key here, which could be a random. Oh, sorry, I'll get this from Clerk eventually. So I'll keep it as is for now, and eventually we'll take it from Clerk and put it over here. Alrighty, that looks good. Nothing wrong in the middleware. Now I can go to index.ts and add middlewares to both the endpoints, the auth middleware here and the auth middleware here. One thing you can clearly see is it's again giving me an error because user ID ka type is string or undefined. If I hover over it, it's string or undefined. So I'm going to tell TypeScript, hey, I know what I'm doing. User ID does exist. And what's the problem here? You should not have this thing not assignable to find first. That should do it. Alrighty. Why is auth middleware giving me troubles here? Have I not imported it? I have. Did I return? Yeah. So I can't return directly like this. I have to put a return here. I can't, this function can't really return something. It needs to return void. So wherever I'm early returning, what does early returning mean? It's a pattern. Rather than doing if else's, you do a if and then return and if and then return. I can't really put them in the same line. If I put them in the same line, I'm returning something from this function, which is not expected. What is expected is to be returning undefined from this function. That covers the auth token and all the type errors go away. Let's quickly try it out. Let me. Oh boy, before that I need authentication. To test this out, I need to make sure the auth middleware is working as expected, which means to test this out, we need to get into the authentication bits. So am I missing any other endpoint, or is the HTTP server that simple? Projects, get projects, get projects. Yeah, I can't think of any other endpoint that we need right now. I could of course be wrong. And if that happens, we'll come back to it. Abhikle. The first part is done. That's the HTTP layer. And if you look at it, it's pretty simple. 2 endpoints, one to create a project, one to get a list of your existing projects, listening on port 3000, and a middleware that does authentication for Clerk, not for us, but for Clerk. I think one thing I'm missing here is I might need to provide the algorithm here. So algorithms, it is not this, it is RS256, and I don't think I need anything else, but I could be wrong, so we'll see. Cool. That's all for the HTTP layer. Let's get into authentication next. God, that will require a little bit of writing, like writing a little bit of the front end also. So let's do both of these things. The next section, let's full screen ourselves. We're done with the primary backend. In the next section, I am going to introduce the front end. I'll show you how you can use Clerk for authentication, makes things very easy. Then I'll connect my front end to the backend and I'll show you how I can, create a project, get a list of my existing projects, so on and so forth. Let's get into that section next. All right, we're initializing a fresh front end project. We want to use Next.js, but we also want to use shadcn because I saw a few components here. For example, the thing coming from the left, which I don't want to write myself. Shadcn provides those. It's like a left drawer. So for that reason, I'm going to initialize a Next.js project with shadcn. The problem is Tailwind recently has released their version 4. I don't know how many of you are facing issues. I am. So I was trying to find the best sort of integration guide for it. I found one here. Let's see if it works. It uses PNPM everywhere, but I'm going to just, I don't know if I can replace this with bun actually, but let's try it out. So for Next.js, start a new Tailwind Next.js project with React 19. This is the command. And of course it doesn't work. So let me replace this with bun. Let's call it front end. No turbo pack, no aliases. Seems like that worked. Let's open front end and let's initialize shadcn in there as well. Again, I'll use bun. Let's select. I always get confused amongst these. I've only used slate and neutral. I'm probably going to stick to neutral for now. Okay, there we go. Let's see if I can add a new _scene component now. So let's add the button component. Again, I used pnpm, which actually shouldn't be a problem, but okay, let's go with 1x. All right, we have a buttons component. Let me try to use it. So let me go to page.tsx in front end. Let me delete everything from here. And let me try to use the _scene button component. There we go. And let's see, does it work? So if I start the front end now, hopefully I see a pretty button and then we're sorted, else this is going to take a few minutes at the very least to debug. That looks right. That looks like a _scene button, pretty styled. Oh, that's because we have a lot of things here. 1 second. I guess this doesn't really affect the button. Yeah, that's fine. Cool. So we're good. Yeah, let's remove that. All right. So let's start to write a very quick janky version of the front end. Create an app bar, create a prompt section over here, and add authentication to our website. So I'm not going to talk much. I'll just quickly code this out. Maybe I'll just fast forward through this section to keep the video short. I'm quickly writing the app bar component and a prompt component here. By the end of it, you can just look out through the folder structure and see how I've written the components. All right, the first version is done. Nothing too difficult. I've added a few components. This is what the app page looks like in the end. There's a div which has some padding at the top, and then an app bar that's rendered over here. That's the app bar. Then there's a div which has a maximum width of 2xl. That means some width over here. Horizontally, it's padded to the center, and there's some padding at the top. That's this padding over here. A big title, a small title, a prompt section, which is this text area, and a button right below it that exists in this prompt component. And lastly, a bunch of template buttons, which is this bunch of default apps the user can click on. Nothing too complicated. Just look through the code base and read through it. The next part is let's add authentication here. So login should take you to a page. When you click on the arrow button, you should actually hit the backend with specific, the project's endpoint with authentication with your header. And then let's go from there. For that, we need to understand a little bit about Clerk. How does it work? Create a project in Clerk, start it in dev mode, so on and so forth. So let's get into the real authentication part next. Right, let's add Clerk authentication. The way to do that is first go to Clerk, sign up for a new account, and create a fresh application like I am over here. As soon as you sign up, you'll see a similar page. Let's call it Bolt T is the name of my app. I'm only selecting email and Google as two options for now. This is what my final front end page would look like, which looks fancy enough. We're doing Next.js. Let's install at Clerk /Next.js. Let's add both of these keys to our env file. Frontend doesn't have a .env, does it? It doesn't, so let me add that. These are test credentials. You can see them, but you can't screw with me with them because these are test credentials. I'll also change them. We don't need this. We have a separate backend. If we were using Next.js for backend, we would have needed this, but since we don't really need any of this. And lastly, they give you a bunch of code which we probably need in just our app bar component. So if I go to appbar.tsx, let's import the sign in, sign out user button component that they have, and pretty much replace our login button with everything that's written here. If the user is signed out, then they should see a sign in button or a sign up button. If the user is signed in, then you should see a user button or a profile button. So I'm going to replace this button over here with this. So if the user is signed out, then they'll see the sign in and the sign up button. If the user is signed in, then they'll see the user profile button. The only thing that's left is wrapping our app inside a Clerk provider, which let's try to do it in layout.tsx. I'm unsure if we can. Do I need to pass something to the clerk provider? I don't know. I thought we did, but seems like we don't. Let's run the front end and see if authentication works. It doesn't. So the thing, I mean, I can add middleware. That's fine. That'll make it work or whatever. But we don't really need that. But if it gets us through this error, it's fine. Where is clerk? Dashboard. Let's update middleware.ts to have this. Yeah, that's fine. App/middleware.ts or global. I always forget. Let's add it over here and see. Refresh. Probably the global folder then. So put it in front end. Refresh. There we go. Application seems to work. Buttons don't look great. We can fix that. But do they work? If I click on sign up, it takes me to a clerk test authentication page. If I sign in via Google and select an email over here, when I come back to this page, I see a profile section, which is great. So authentication is done on the front end. Sure, it needs a bunch of things on the back end, but at least on the front end, everything looks great. The only thing that's left is one prettifying the sign in and the sign up button. Simple enough, we'll do it down the line. The second thing is the prompt.tsx file, which has a send button. Whenever the user clicks on the send button, we need to do a bunch of things. Like eventually we'll do 10 different things here. We'll get the worker URL, try to connect to the worker, redirect the user, so on and so forth. Abhi ke liye, we simply need to send a request to the backend. So let me add Axios. And do a, come on cursor, you're smart enough to figure this out. Nope, seems like it isn't. Slash, what was our backend endpoint? Project. Let's pass in the prompt, which is something that the user put here. So let me add a state variable. Let me change text area to update the state variable whenever there's a change. And we can pass the prompt to the backend, await this, response equal to this. And let's log response or data. But one thing that's left here is what, guys? What do we need? We need to pass in the headers. We need to pass in a token that comes from clerk. So const token equal to await get token, where get token is a function that comes from use user. I think it's use auth, but use auth. Yeah, there we go. So there's this hook called use auth that clerk provides you. It gives you a get token function. We call get token over here. We get back the token, and this is the token that we're going to pass to the backend. And we'll hope that the backend is able to decode this token and the middleware works as expected. Where was our middleware? Right here. And it tries to get the authorization header. Do we split the token? We did not. So const auth header is this, and const token is, if the auth header exists, then auth header.split space and the first element over there. So this is what we send from the front end, and this is what we get over here. And making, hold on, what's up here? Making sure we're sending the right thing over here as well. Perfect. So let's try it out. Let's do an ND to start the front end. Let's open another terminal. App/primary backend. Let's start the backend. One index.ts. So the backend did not start because port 3000 is already in use. So let's do a few things. Let's go to index.ts in the backend and replace this with 8080. Let's go to, yeah, this looks wrong. Let's create a top level file or a file in the frontend folder called config.ts where we say export const backend URL is localhost colon 8080. And here I'm going to send a request to backend URL / project. Now let's try it out. Let's go here and see. Of course, there's a problem because this needs to be a client component. Refresh. And this time, hopefully, if I write some text here and click on inspect and hit the arrow, it fails. No apparent error, which probably means the backend crashed. Or the backend isn't even up yet. Let me start the backend. Let me try that one more time. Send. And this time we got back a 500, which means the backend crashed because the JWT crashed. So yeah. Oh, one big thing I forgot is in the backend.env, I haven't replaced the JWT public key. So now I can go to the Clerk dashboard after all of this is done. I can click on configure. I can go to keys somewhere here, API keys, and I can copy the JWT public key. I can paste it over here, and hopefully that does what it's supposed to do and everything works. Now let me restart the backend. Try to send it one more time, and this time also we get a 500. Again in JWT verify. So let me go to middleware.ts. And where are we doing JWT.verify? Right here. So I'll log this and see does it indeed exist. Send the request, and okay, that makes sense. I think I need to do this. Cool. Let's try that one more time. Refresh. I did not have to refresh this. Send the request, and this time again a 500. But this time public is fine. It says undefined is not an object. Decoded.payload.sub is not an object. So middleware.ts, and let's log decoded here. Let's see what decoded gets. It gets this, and there's a direct sub field here, which makes sense. So let's do a decoded.sub, and that contains the user ID of that specific person. Let's try it out again, and this time, as I put an entry here, I'm able to put projects in the server. If I do a GET request, I'll get the projects from the server. How can I confirm? I can do a PSQL. The password is incorrect. I can PSQL into this server. Actually, I have to first do a docker exec-it container ID for Postgres sh, and then I can do a PSQL-u Postgres. And if I do a /dt, you can see the projects table. If I do a select star from project, you will see I have a bunch of these entries for the specific user ID. This is the prompt. This is the description, which I think was just hard-coded for now, which is the first line over here. Perfect. Authentication is working. I'm able to put projects in the backend. One good thing would be if I hover to the left, the drawer opens. I see my existing project similar to Bold. So something like this happens. Let me quickly again sprint through this, and let's fast forward this section. I'll add a sidebar that opens. That shows you the list of your existing projects, and then let's go from there. Alrighty, I have written a bunch of front-end code, nothing too complicated. Everything is moved to dark mode. We have a left sidebar that opens you and shows all the existing chats that you've done. For example, on February 28th, I've done all of these chats. Read through the code, nothing too complicated, pretty simple front-end stuff. Next up, let's get into the the real logic of connecting this to an LLM, the worker code primarily. If you remember the architecture, it looked something like this: a front end sort of done, a primary backend sort of done. Postgres primary backend is connecting to it. Now the front end needs to talk to a router service. If you remember, the router will route it to the right worker. We'll write that eventually. Abhi ke liye, we'll assume there's a single worker that we have. The front end, whenever the user reaches the arena screen, connects to the worker. And on this worker, we have an HTTP server running. Whenever the user forwards a prompt, prompt goes to the LLM, LLM gives you a response, you put it in a file, dump the file to S3, everything we discussed already. One more thing that will be running on the worker would be VS Code on some specific port. This worker is supposed to expose two different ports, for example, one HTTP port for interacting with the front end, heartbeating, things like these, and one VS Code port, or VS Code running somewhere, so that the front end can edit the files on this server directly, and without having to, there's a sync of file system over here and file system over here. The front end has all the capabilities of VS Code exposed via some other port over here. So this is the logic we're writing right now, the HTTP server and the VS Code logic. Let's try to containerize it somehow. I mean, I'm thinking too ahead right now. For now, let's just write this much logic. Let's write the HTTP server that can accept the prompt from the user, follow prompts, things like these, talk to the LLM, store things in the file system, and expose VS Code on the server so that the front end can connect to it and update the file system manually as well. This part we need an LLM for. So I was just checking a while back. I have 0 credits in Claude or the other one, ChatGPT. So I'll most probably use Gemini. Gemini is free. That's good news for you as well. So if you're following along the project until this point, you don't need any credit card. You should be able to use the APIs that I'm using for LLMs. And what is the LLM we're using? We're using Gemini. With that, let's get into coding the worker next, specifically the HTTP server, LLM calls, things like these. All right, folks, I spent like 3 hours coding this. I recorded the whole thing, but I feel there'll be very little retention if I post the 3-hour video of me struggling and debugging through this. So I'm hiding a lot of challenges from you. I'll explain all of the challenges that came, and how did I build the worker talking to the LLM. Backing up to S3 isn't done yet. Talking to the LLM, putting things in the file system, exposing VS Code that the user can see. So now we have a worker backend, which the frontend will eventually connect to. I haven't written the frontend yet. The frontend will have VS Code, which is a virtual VS Code that's running over here. Bolt doesn't do this. Bolt uses web containers, much leaner approach. We have not done that. We have taken a slightly more expensive approach of starting VS Code on a server that you're connected to on your worker directly. Let's say this is exposed on port 8080. And whenever you're chatting, whenever you want any improvement, you're going to chat here. And you're going to talk to an HTTP service running on the same worker. So this HTTP logic I've written a Docker file for starting VS Code for now locally on my Mac machine. And then eventually we'll deploy it to a virtual machine, and then we'll auto scale the virtual machine. So let's go through the code. The most difficult bits here were engineering the prompt. The prompt is very heavy, highly inspired from the Bolt prompt. And parsing the response from Bolt. The problem that, not a problem, but generally the thing with LLMs is, you send a query to the LLM, hey, please create a chess app. And it responds back with 10 files. You have to create a whatever app.tsx, chessboard.tsx, piece.tsx, so on and so forth. And you need to parse this response. It's plain text response that you need to understand. These are the contents of app.tsx I need to dump in a file. These are the contents of chessboard.tsx I need to dump somewhere else. The LLM might also respond with, hey, you need to install a dependency. You need to run this command, npm install, I don't know, react-web, let's say. So that also you have to install this command that the LLM is telling you to run. You need to run. The LLM is not going to give you a very clean response. It's your job to make sure you tell the LLM, okay, bhai, aisa response diyo, give me a response in a certain format. And then you need to parse that. That was the most difficult bit, because the LLM can hallucinate. You have to make sure the prompt is very strict. And then there were a bunch of other challenges. We are using Expo navigation, not an old version of React, not really an old version, but basically there are various ways to do navigation. Navigation is going from one page to another. We are using Expo navigation, which is very similar to Next.js routes if you've seen them. Page.tsx, course/page.tsx. So we need to tell the LLM that also. LLM, we are using Expo navigation for navigating through the files /screens. So use that. So that's what the prompt was engineered around. So let's go through the code. I've added 2 folders for now, worker and code server. There's a third one I've added. I haven't written anything here. We're still supposed to write the worker orchestrator. But the worker is where primary of the code is written, and code server is nothing but a Docker file, which if you start a remote VSCode instance on the machine. So this is a Docker file. This is the actual HTTP code. Let's go through the worker code really quickly. Not really quickly. Let's spend some time here. It has a bunch of files that I've added. Let's kick things off with index.ts. Let me remove these. Index.ts is very simple Express server. Amongst the many dependencies, I've introduced Anthropic as one of the dependencies because we're using Claude. You can use Gemini, even though I've seen it not perform great with these prompts. You can use OpenAI, that'll probably perform well. Anthropic is performing well. T-Research, I don't know, probably will. So I've imported this as a dependency. I've exposed one route here called prompt, which is the route that the user will hit whenever they're chatting with us. So whenever they type something here, okay, create XYZ, create a chess application, make it prettier, there is a bug, please fix it. All of those will be an HTTP call that comes to this slash prompt endpoint, which exists directly on the worker, which exists on the worker right here. That means the worker can receive it, talk to the LLM, and start to dump files based on the LLM, what the LLM responded with. So if you look at this prompt endpoint, there are 2 inputs that the user gives: the prompt, create a chess application, and the project ID, which project they want to talk with. For example, here when I'm on this screen, I'm on the to-do app implementation project. It will have a ID associated to the project. If you remember, initially we've already written it. And these are the 2 inputs that we expect the user to give us. The first thing we do is we add a prompt to the database. Okay, the user has given us this prompt. So the user will give us 10 prompts. All those 10 prompts will be dumped to the database. For this project ID, this prompt was given by the user. So one more thing I've added to prompts is, if you look at the schema.prisma now, prompt has another field called type. Ki kiska prompt hai? Was this a user prompt or was this the LLM response? The thing with LLMs is, if you've ever opened ChatGPT, what you're doing is you're sending it a series of messages. That's fine. For example, create a chess app, and then it will create a chess app. So this is your user message. What it's responding back is the LLM message or a system message or an assistant message. Then you can ask it a follow-up question. When you ask it a follow-up question, what you're effectively doing is giving it the context of the history of prompts. Okay, I gave this first question. It responded back with another question. I gave it another question. After this is done, I can give it another question. It's taking a long time. That's taking really long, but you get the idea. As I keep sending messages, what I'm sending is, here, I gave this first message to you. You responded back with a very big message. Then I gave you the third message. Then I gave you the fourth message. It's a list of messages you have to send to the LLM whenever you're talking to an LLM via an API, which is what we're doing over here. First time you'll only send it, create chess app. But if there's a follow-up question, you need to send it, create chess app, the response, the very big response that the LLM returned you, and then the follow-up question, which could be, clean it up or make it prettier. So we have to have this history of prompts somewhere, so that whenever follow-up questions are asked, we can give the LLM complete context of the conversation. So all these messages, be it our messages or the LLM messages, need to be dumped in the database. So this prompt database or prompt table, which is a one-to-many relationship from the project. Every project has a series of prompts: user prompt, assistant prompt, user prompt, assistant prompt. All of those are dumped into the database. This is me dumping the user prompt. Then I fetch all the prompts from the database. Ki abhi to user ne ek dala hai, but what are the existing prompts in this specific chat? I get all of them, and that is what I forward to the LLM. Ignore this artifact processor, these 2 lines of code. We'll come to these. But focus over here. I already added streaming here, so remove the to-do. This is me forwarding the request to the LLM. What am I saying? I'm telling the LLM, hey, client.messages.stream. Where does client come from? Client is the Anthropic client, which I've initialized over here. Harkirat, where have you passed your API key for Anthropic? I've passed it in this .env file. So this .env file has I can just show you, I can remove it by the end of the class. But I've added an Anthropic API key over here, which is an API key I got from my Claude dashboard. I can show you really quickly. If I go to claude.ai and try to open my API dashboard or API console, go to get API keys. I've exported an API key or created an API key over here. This is probably the one. And I've also put in like $25 in it. I don't know how much is remaining now, $23. I've spent like $1 debugging or coding before this. And you will need this. If you want to try it for free, then use Gemini. But again, Gemini does not, at least in my experience for this specific prompt, does not perform really well. Okay, so I've initialized an Anthropic client. I forwarded all the prompts. In the history of chat for this project, what all prompts were written? The way you forward prompts is you give the prompt content, okay, this is going to be create a chess application, and then whatever the response the LLM gave, and then your follow-up question, and then the response that the LLM gave, and then the role. Okay, was this the user asking a question, or was this the assistant or the LLM responding back? So the complete chat history is what you forward. The last user message is what it understands that this is what I need to do, but it also has the context of the complete history of the chat. This is important because whenever you're calling an LLM, the LLM doesn't have any state. उसको नहीं पता कि उसने क्या ऐप बनाई थी. It doesn't remember the app it created. You have to tell it कि hey, I asked you to create chess. You created this very big chess app. Now I want you to fix this follow-up thing in there. So that is why you have to send it a history of messages. System prompt is super important. We're getting to this. ये क्या होता है? The model I want to use, that's Claude 3.7, and the maximum amount of tokens that I want in the response. Keep this as a very big number because we're writing code, which is a bunch of files, which could be a lot of tokens. So if you restrict this too much, your response will be cut off from time to time. If you make this too big, someone might exploit you and ask the LLM to run infinitely, and it'll run infinitely. You run out of credits. So keep this a reasonable number. 8,000 is good. And now we are using this stream endpoint. There's another endpoint for getting the response in one go. We want to stream the response. Okay, जैसे जैसे response आता रह रहा है, वैसे वैसे I'll start to create the files. If the LLM told me to create file number 1, I'll create file number 1. So this is again where the artifact processor comes. As I said, there are two big parts to this. One is telling the LLM what to do. Two is parsing the response from the LLM. So that is what I've called the artifact processor. We'll read through the code of this very soon. It was written in a very ad hoc fashion, and I'll talk through this very soon. But long story short, it's very hit and trials are written, and then I wrote a bunch of tests for this to make sure it works the way it's supposed to work. But I had to write this in a very ये चल रहा है, ये नहीं चल रहा है, ये चल रहा है, ये नहीं चल रहा, करते I was able to reach some logic in the processor that works. ठीक है, as the LLM response, I tell the artifact processor कि यार ये और response आया है, this is more response that came, and then I tell the artifact processor to parse it. कि यार if a new file has been generated, please dump it to the database. If there is a command I need to run, npm install, npm run dev, please run that specific command. That is what this parse function does. And I keep maintaining this local variable called artifact that I need to dump to the database eventually, right? Whenever Claude finishes its message, I need to dump this prompt in the database as well. Okay, this is what the LLM responded with, and the type of this is system. The type of my messages is user. The type of the Claude messages is system. It means it's a system message or an assistant message. This way I have a full history of chat between me and the LLM dumped in my database. And that's it. You don't need to return the response. You can return anything to the user, done or processing, whatever. And in the background, these messages are getting streamed from Claude, and you're able to process these as they come by. The question is, in what format does Claude respond back? And how have I told Claude कि भाई ऐसा response देना? Tell me which file to create like this, which command to run like this. That all exists in the system prompt. Where does that exist? In the system prompt. What is the system prompt? System prompt basically means that this is what the user is asking you to do. These are the messages that the user is sending you. This is what you're supposed to do with those messages. That's defined in the system prompt. This is a very big system prompt, heavily inspired from Bolt. Bolt ka some old version was open source. Now it's not open. They're not pushing any of their new code to GitHub. But their old code that was there, very nice prompt that they've written, covered a bunch of edge cases. Few things I had to add on top. But if you try to read through the system prompt, what does it say? You are Bolty, an expert AI assistant, exception senior software developer with a vast knowledge across multiple programming languages, frameworks, and best practices. These are your system constraints. Now for Bolt, it's something else. For us, it is you are running inside a worker, a Docker container that is running in a Node.js environment. Additionally, there is no C++ or G++ compiler. Git is not available. Prefer writing Node.js scripts instead of shell scripts. When choosing database and packages, prefer that options that don't rely on native binaries, which basically means Node.js code jitna zyada ho utna better. If you are adding native C++ code, then that may be a problem because we don't have C++ on the worker. It's not that we can't add it. We're just avoiding it. We want to use native libraries. We want to keep a lean Node.js backend and nothing else. These are the commands that are available to you, and you are creating a React Native Expo app. This is the thing that I added because we are specifically focusing on React Native Expo applications. And all the code should be written in TypeScript. Cool. That's some system constraints that we're telling it. Formatted like this, 2 spaces. Again, comes from Bolt. System prompt, just copy pasted here. Message if formatting, you can make the output pretty by only using the following HTML elements. Again, this comes from Bolt, but we don't really need it. We're not using HTML. We can actually remove this specific section of the prompt because we're not using HTML. This is not a website. This is a mobile application. So these HTML elements that are written are not really needed. You can't really write these in a React Native application. They'll cause a problem. So let me remove this. You don't really need this or this. If anything, we can replace this with a bunch of React Native elements, but let's just remove it. Artifact info. This is the most important thing. Artifact. This is a jargon that we're going to use from this point on. Artifact means there are various ways for you to store your code base. Generally, you store it on GitHub, right? But when you're talking to an LLM, the way Bolt stores the code is in something called as an artifact. What is an artifact? It's just one very big file that has all of your code in a certain format. You can write your code in 5 different files, push it to GitHub. That's one artifact that you have created. Your artifact is, the standard artifact जो GitHub पे लोग push करते हैं generally. But when you're talking to an LLM, you can't really give it a Git repository URL, or you can't expect a Git repository URL from it. तो हम उसको कह रहे हैं कि भाई create an artifact. And what is an artifact? Let's read through the whole thing and then I'll explain what an artifact is. But Bolty, the name of our application, creates a single comprehensive artifact for each project, which contains the shell commands you need to run, the files you need to create, the folders that you need to create, the files that you need to delete, files that you need to update. We are telling the LLM कि तुझे artifact बनाना है. You're supposed to create an artifact which will tell us one of these 5 things. An array of these 5 things. Okay? Create this file, create this file, create this file, run this command, then delete this file, so on and so forth. And artifact instructions are a bunch of things you need to follow. So इसमें some of these, everything from here was what Bolt had, and then a few things I've added myself because we're using a mobile application, we're using Expo navigation. So all the 5 things that you see on the top are written by me. Some of these the rest of them are mostly written by Bolt. Or for example, exist in their system prompt, but मैंने थोड़े changes किए based on what we need. So a few things. Assume that you already have a React Native project initialized. So what was happening was when I was talking to the LLM, the first command it was running was npx expo create. It was creating a fresh React Native application, which I said I already have that. So don't create a fresh one. Assume it's already initialized. When I was parsing it, sometimes the LLM was returning commands like this: npm install, dep1, dep2, dep3, dep4. Single command that has everything. My parser isn't yet smart enough to do that. My parser expects each command is present independently. So npm install dep1 followed by npm install dep2. So I told it कि भाई एक करके दियो. Each npm install command should be separate. Do not give commands together like npm install dep1 dep2. Give separate commands. Don't use aliases. Again, I was seeing some issues with aliases, so I said कि भाई use ही मत करो aliases. Use relative paths throughout the project. What are aliases? Import x from @/components. I said don't use this, just do // components. Don't use aliases through the project. We can fix this, but quickly I wanted to run this, so मैंने कहा कि भाई aliases use ही मत कर. I'm seeing some issues in it. We use the latest version of Expo. The folder structure has these things. We are using Expo router for navigation or for routing. The problem was कि it was not assuming I'm using Expo navigation. It was adding navigation libraries natively. So the initial project that I've initialized uses Expo navigation. They were doing something else. So assume this way कि if you're using Next.js, I was using the app router, but the LLM was returning me responses assuming it's the pages router. So I clearly told it कि this is the navigation library that you're using, so change the code based on that. बाकी ये सारे Bolt के default वही हैं कि think honestly and comprehensively on the artifact. This line onwards it becomes important कि wrap the content enclosing in a bolt. So basically long story short यहाँ भी सब ये लिखा है कि finally response कुछ ऐसा दियो. Give me response that looks like this. This Bolt create an XML. XML is similar to HTML. That looks like this. Bolt artifact. Give an ID to this specific artifact that you're creating. Give it a title. And create a bunch of Bolt actions. Think of this like div tags or whatever. I can name this whatever. Bolty actions, Harkirat actions. But the point is the LLM needs to know कि भाई response ऐसा देना है. Response, if you want me to create a file, give me an XML tag that looks like this. If you want me to run a command, give me a XML tag that looks like this. I'm telling it clearly by giving a bunch of examples over here. For example, another example is if the user tells you to create a snake game, Response should look like this. First, give some plain text. Okay, I'll be happy to help you with, building a snake game. Then create a top level bolt artifact tag. Create a top level bolt artifact XML tag. इसके अंदर write all the actions that you need. This one is create a file at package.json with this content. This one is run the command npm install save dev wheat. Type is shell, which means this is a command that you need to run. This is create another file called index.html. This is run another command, npm run dev, so on and so forth. So we are clearly telling the LLM कि भाई ऐसा response दियो. This is the artifact that you have to create. I know you can write code. We know the LLM can write code, but we need to tell the LLM explicitly कि code ऐसे लौटाइयो. Return me the code in this format. Basically a bunch of XML that you need to return me so that I can parse it correctly. ये XML को मैं backend में फिर parse कर लूँगा and I'll understand कि अच्छा I'll create this file, I'll run this command, I'll create another file, I will run this command. So this is me clearly telling the LLM कि ऐसा response देना है. These are a bunch of examples and ऊपर जो मैं show कर रहा था, all of this is us telling the LLM the same thing कि यार for each bolt action that you have, add a type field. That could be a shell or a file. If you want me to run a command, then write bolt action type equal to shell. If you want me to create a file, bolt action type equal to file. Then give me all the contents inside the XML. So whatever I've written in plain text over here is what I have given it as examples later as well. Okay, this is one type of action, this is one type of action, so on and so forth. इसको छोड़ के कुछ है? No, that's it. It's just a bunch of examples at the end, and that's your system prompt. It's actually not too long. I thought it will be really hard to explain, but hopefully this is easy to understand. This is me telling the LLM कि भाई ये करना है, and the most important thing here is कि please जो examples आप लौटा रहे हो इस तरीके से लौटाने. If the user has asked you to do this, then your response should look something like this: some plain text explaining what you're doing, a top-level XML tag called bolt artifact, inside which you have a bunch of bolt actions that can be of two types: either type equal to file, which means I'm supposed to create this file, or type equal to shell, which means I'm supposed to run this command. That is all that I've told the LLM to do. Now, hopefully, the LLM will be smart enough to understand the system prompt. Smart enough to know कि अच्छा chess app बनानी है, React Native Expo में बनानी है. I'm only constrained in this environment. I only have these commands that I can run. This is the navigation library that I'm using. Hopefully, the LLM responds correctly. The LLM responds with something like this, and then as I get the LLM response, I need to parse it and do the things it is asking me to do, which could be creating a file or running a command. So now, let's look at the code one more time. यहाँ पे I've told Claude to do something. I've given it a very big system prompt. I've given it the things it's supposed to do. Create a chess game. It is responding back with text to me in real time. Text one, text two, text. धीरे धीरे करके it is appending text and returning it to me. I need to process that. The LLM might first return me just this much, then 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 this much. And karte karte, the first tag might come back to me. When the first tag comes back to me, I want to create this file. And then it might give me this much, this much, this much, this much, and this much. And then when this much comes, I need to process the second block. मुझे incrementally in blocks को process करना है. I need to do what the LLM is telling me to do, which could be creating a file or running a command. So all of that logic I have written in the artifact processor. So now let's go through the artifact processor that is supposed to take an artifact as an input incrementally, धीरे 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 करके artifact आता रहेगा, and supposed to process it incrementally. The way I've written it is, again, this is what the final response would look like, mota mota. I wrote this for testing purposes, just to keep testing this artifact processor. Then I eventually wrote tests for it. But basically, what does the artifact processor need to do? It has three member variables. The current artifact kitna bacha hai, it might have processed half of it is still left. So it keeps deducting whatever it has processed upar se, and we keep adding whatever the LLM is telling us niche. So this variable contains what is left to be processed. We initialize it to empty. If you look at it here, I initialize it to an empty string, and then I keep calling .append, which will, if you look at it, keeps appending to the current artifact. कुछ नया आ गया, कुछ नया आ गया, कुछ नया आ गया. This current artifact keeps on getting bigger and bigger as the LLM responds. And I have two more functions that I expect as inputs: on file content, on shell command. Okay, the artifact processor is supposed to call this function whenever it feels like a file banani hai. It is supposed to call this function whenever it feels like a shell command needs to be run. So it is the job of this artifact processor to parse the response, and based on the response, as it keeps on getting more and more actions, it needs to call either this function or this function based on what kind of command is running. The parse function here is the most difficult one. this is my implementation of it. Very ugly, kuch karke karte wrote tests for it, tested it a lot and made sure it worked. Let me share how I've done it, but feel free to write your own implementation. You can use an XML library also that parses XML. I have not done that. I have written very ad hoc parsing, but there are XML libraries. I tried that first, but bun ke saath they were facing some issues, so I chucked it and I wrote my own parser myself. But if you're using Node.js, most probably you'll be able to use an XML parsing library. You don't have to do all the things that I've done over here. This variable tries to get, so for example, let's say हमारे पास इतना आ गया है. We have received this much response from the LLM. The first line of code, this line, tries to get the latest action start, which means this line के latest जो action है, जो currently best top level action है, वो कहाँ पे start हो रहा है? This thing right here. Then it tries to get latest action end, which means कहाँ पे end हो रहा है? This thing right here. These two line numbers are what are stored in these two variables. At what point does this start? At what point does the latest action end? If there is no action that needs to be currently processed, we check it. We say हमें process नहीं करना. In fact, I can add another check here. Okay, if an action hasn't ended, then also I don't need to process anymore. This depends on you. Bolt doesn't do this. Bolt ऐसा करता है कि if there is an action that has started, it starts to fill the file धीरे. For us, we wait for at least one full action to come. वो पूरी की पूरी file आ जाती है, then we dump the file. We don't incrementally dump the file. That's a better approach. The user will see, धीरे file बन रही है compared to एक file एकदम से बन रही है. So what we have done is not that. I can add another if check over here, and if the action hasn't yet ended, I will not do anything. I will not process at all. But if the action has started and the action has ended, then I try to get the type. Okay, is this of type shell or is it of type file? How do we do that? Again, read through this. There's a lot of ad hoc logic, but if you look at it, what is happening here is I get the start line, which is this line right here. Then I split it by type equal to, which means I split it into an array. First part of the array is this. Second part of the array is this, and then then I split it again by space. I'll come to why this is, but mostly the important thing is this. I split it by closing brace, which means इतना तो हम पे आ ही गया था, type equal to shell closing brace. I split it by this, which means an array is created with this as the first element, or sorry, shell as the first element, and then shell is what I store in the variable. The other thing I've done over here is first split it by space and then split it by closing brace, because if you look at this guy doesn't really end over here. इसके बाद there is a space. उसके बहुत आगे जाके there is a closing brace. So when I split it by type equal to, two elements get created, element number 1, element number 2, and then when I split it by space, then two elements get created, file, and this, and the first one over here, file, is what I need. So read through it. It's a lot of human written logic that I wrote by banging my head on the table over here, and eventually was able to make it work for a bunch of examples. So I went with it. This is very first principles approach of you don't have an XML parser, you're sort of writing your own XML parser. But feel free to use an XML parser if this feels very hard. So this gets the type. This gets the content. Content क्या है, मतलब इसके अंदर क्या था? npm run start or the contents of the file. These two we get in these variables. This variable and this variable. Now if the type is shell, and again if you look at it, there are extra quotes over here because यहाँ पे there is shell with double quotes. When we try to parse this file, by the end of it, what we are left with is this, with the extra quotes, which is why the if check over here checks shell with double quotes. You can of course change that over here. If it is of type shell, then we try to get the actual shell command that the user wants to give us, which is this thing right here. That would be, so latest action content is the whole thing. What we want is just the contents inside. So that is what get in this shell command variable. How do we get it? We try to split it by /bolt action, which means अगर ये पूरा का पूरा आया होगा, then if we split it by /bolt action, which means this will be the first variable, and an array will be created with this as the first variable. So that is what we get in this shell command variable, and we remove this from the current artifact. We say कि यार current artifact खत्म हो गया, or that specific, we remove all of this from the current artifact. भाई ये तो process हो गया. So that is what this line of code does. It changes the current artifact to remove a few things from it, and then we call on shell command. We tell the parent class, whoever initialize this class, कि भाई shell command आई है, इसको run कर दो please. And the same is true for on-file content. I know it's very hard to digest, and I have written it so I understand it. I'm sure you don't. So feel free to take it as a black box and just focus on the test. कि अच्छा ये चल तो रहा है किसी तरीके से, but we don't know कैसे चल रहा है, but चल जरूर रहा है. How? Because I've written some tests for it. Could have sworn I wrote tests. Where did they go? Oh, there you go. Worker.test.ts. So I've written 2 tests just to make sure it does work, because मुझे भी नहीं पता था, मैंने भी कुछ चूज करके लिखा था. It was working for some cases, not working for other cases. So I just wrote tests for it to make sure it works as expected. The first test takes this action as an input, creates a new artifact processor, and the first callback over here is file path or file content I. The second callback over here is this is the command that you need to run. And inside these I'm checking here, this was indeed called with file path set to source/index.js. This was indeed called with file content set to console.log hello world. So I'm making sure that the first callback, whenever it is called with the right inputs. The second callback, you need to run a command, is being called with npm run start. The test is pretty much checking given this initial artifact, if I try to create an artifact processor, if I call parse on it twice, I call parse on it twice, 2 बार, because एक बार वो इसको parse करेगा, second time it will parse this. When I call parse twice, does this get called with the right inputs? Does this get called with the right inputs? So the test is what makes me confident that it works. The implementation is very hard to read, which is why I can totally get if you don't understand it or don't want to dive into it. Write your own implementation if this feels ugly. It does feel ugly. The tests are what make me confident that it works. And the second one is actions with appends. कि इसमें मैंने ऐसा किया कि initial bolt action is this: create an artifact processor, expect file path to be this, file content to be this, shell command, expect shell command to be this. After I parsed, I appended something more on it, and then I parsed it a few more times just to make sure कि even if I'm appending more and more things as the LLM is responding back, and I'm parsing them again, it does work. So I added 4 action blocks. 2 यहाँ पे थे. One more I added. I parsed 4 times. 1, 2, 3, and 4. And in the end, I checked that artifact.current artifact khali ho gaya. All the 4 actions were processed. They were removed from this current artifact variable. So totally get if you don't understand it. Hopefully you do. Maybe it's too easy for me because I have written it, and so totally fine if you don't understand it. I hope you understand what you need to do. I hope you understand what the artifact processor needs to do. You have to create a class like this that is getting response from the LLM and parsing it and doing the things the LLM is telling it to do. How have we used it? We have initialized an artifact processor here. We have given it 2 callbacks: on file update, on shell command. These exist in a separate file. I'll show you these very soon. And as the LLM responds with something, I keep calling parse. कि अच्छा ये text आया, parse कर दे. ये append this text, parse. Append this text, parse. If it's partial text, parsing will do nothing. If a full action came back from the LLM, then parsing will process the action, call either this or this, and then remove it from the current artifact, and then more and more artifacts will keep on getting added as time goes by. Finally, when the whole message comes, I dumped it to the database so that the database has a list of the prompts that I gave and the LLM responded with. The only thing that's left now is on file update and all shell command करते क्या हैं. The artifact processor is processing the artifact that the LLM is giving and telling this function कि यार ये file बना दे या फिर ये command run कर दे. Either run this command or create this file. So on file update, simple. It just writes to a file, right? So I've created a folder in /temp/𝗶𝗶𝗶𝗶_worker. This is where my user code will be held. मैं अपने user का code यहाँ रखूँगा, and whenever on file update gets called, I just call bun.write to write to that specific file. Whenever on shell command gets called, sometimes these have multiple commands in it. For example, npm run build and npm run start. So I split the commands by and. And से पीछे क्या है और and से आगे क्या है. And then all of these commands are run one by one. I also log this. So, I could clearly see in the logs that it was running the first command, running the second command, running the third command, like that. So in the end, you can forward this to the user as well. So the user knows what is happening. And you can also see this in your terminal. File 1 generated, file 2 generated, file 3 generated. We just call bun.spawn sync, which means synchronously try to run this command, which means the thread will be a little busy here, but that's fine, because we only have well, that's not fine. You can also spawn this asynchronously, either is fine. And then I just log the std out and std just to see if there's something that the terminal responded with, or if there's some error that happened when running this command. So ये 2 functions हैं. And where do these functions get called from? These two functions get called from the artifact processor as the artifact processor feels कि अच्छा file needs to be created now or a shell command needs to be run now. तो ये समझ आया थोड़ा थोड़ा. Let me create it pictorically. I think code तो मैंने बहुत ज़्यादा दिखा दिया, but pictorically what is happening is if this is our backend and this is the LLM, then in the backend I have this artifact processor. As the LLM gives some response to the backend puts it in the artifact processor. It tells it कि यार एक bolt action थोड़ा सा तो आ गया, bolt action came, AC came. Then as LLM responds more, it tells अच्छा ये पूरा का पूरा आ गया, bolt action, and then whatever type equal to shell came. And then the LLM responds more, it tells npm run करना है. And then the LLM responds more, it tells कि npm run start run करना है. Then the LLM responds more कि bolt इतना ही. Then bolt action. As the LLM responds, we keep telling the artifact processor that we keep calling the parse function here, and the parse function will eventually understand जब ये पूरा का पूरा आ जाएगा कि अच्छा this command needs to run. So this artifact processor calls another function that we have written called on shell command, and in on shell command function के अंदर we have written the logic to on shell command के अंदर we have written the logic to spawn that specific command, run that specific command in this specific folder. So what does CWD mean? In this current working directory, run this specific command that the user has given us. If the user has told us run npm run start, then the command that goes over here goes like this: npm run start, something like this. So that is what command.split space does. कि अगर the LLM told us to run this, that is what we're running over here. That is what we're telling the operating system to run. That is why I've called the file os.ts, because it's doing some operating system things. It is running a bash command on the operating system. It is creating a file or updating a file on the operating system. Took me 3 hours to write. Hopefully, I don't know, some 20 minutes to explain. Hopefully easy to understand. If not, एक बार एक demo भी देख ही लेते हैं. And hopefully that makes it a little easier. But mota mota, there is just one endpoint that the worker exposes, the prompt endpoint. Where is this prompt endpoint hit? From the prompt endpoint is hit from this chat. जब भी मैं chat पे कुछ करके enter दबाता हूँ, whenever I press enter, it hits the HTTP layer, talks to the LLM. LLM does this whole magic that I told you. Send to the archiver, process the message, send it to the processor that actually dumps files in the file system or runs a command. And this layer sort of, that's all you need on this layer. The other layer that's left is the VSCode layer. Okay, the same machine, the same worker machine that we have also needs to have the file system exposed somehow on the browser. The browser needs to be able to explore LLM जो लिख रहा है. You need to see that over here. For that, we're starting a remote VSCode instance. The way to do that, I mean, I don't know how many of you know, but VS Code is open source. A web version of VS Code is open source. That's how, products like Cursor have been built. They've built on top of VS Code. They've not written everything from scratch. So here is, one implementation called Code Server that lets you run VS Code inside the browser. That's the one that we are using. What is Code Server? As you can see, VS Code inside the browser. All you have to do is have a server where you're running Code Server, and then the browser can talk to it using an endpoint. And you will see the whole VS Code UI over here in the browser. So how do you start this? Go through the installation steps of Code Server. In the end, you can run it using Docker. So you can simply run this. Docker run this. That would work. You can run Docker run coder.com/code server and expose a few ports, of course. But the problem then is that when you start this, it doesn't have node in it. So that's why I've created a modified Docker file. I know that मुझे ये तो start करना ही है. I want to start Code Server, but I also want to have npm or node installed in there. So this user root changes, the user in this Docker file to be the root user, so that I can add a few files. More technically, just add Node.js to the operating system. If I don't add this, then I don't have the permissions to add Node.js to the Docker file. So user root will change the user. I'll install Node.js on the machine. Then I'll revert the user back to coder. I'll expose the endpoint, not really needed, but chalo dal diya hai. And then finally, the command that I run is the same command that runs in this Code Server Docker file, which is start Code Server. I have set authentication to none just to keep things simple. We should eventually change this to have some sort of authentication. And this is where we want it to be exposed on port 8080. And this is the folder that we wanted to open by default, /temp/boltworker. यही तो folder था ना जहाँ पे we were storing everything. Of course, Docker file में वो different होगा. Basically, what will happen is if this is your worker machine, यहाँ पे there is a folder called /temp/bolty-worker. यहाँ पे there is a Node.js process running natively. Let's say there is a Node.js process running that is constantly changing the files in here, that's constantly updating things over here, running commands over here. And then inside a Docker container, I repeat, inside a Docker container, I run code server and I mount this /temp/bolty-worker folder to /temp/bolty-worker here, so that whatever changes the user makes from their browser, in the end, the user is connected to this Docker container through a port 8080. So they can only change his files in this Docker container. I need to mount this file specific folder onto the host machine, ताकि जो changes LLM कर रहा है, the changes that the LLM are making are synced with the changes that the user are making. Both of these should point to the same folder on the host machine, which is why I've added a volume over here. And of course, I will add a port mapping to expose this. Now, if you don't understand these terms, two terms I've thrown at you, volumes in Docker and port mappings in Docker. You should read about them. I have a Docker tutorial thingy where I've covered this on YouTube. But I'm not going to the depths of this. Okay, what exactly are volumes and port mappings? But when I write /temp/bolty-worker here, I don't mean on the host machine. I mean on the Docker container. But when we are starting the Docker container, we will mount this folder on the container machine or the Docker container over to the host machine. How do you do that? Docker run. Firstly, I will have to build this Docker file. I've already done it, but you have to go to the apps/code server folder. You have to build this Docker image by running docker build -t name of your image and then dot. Again, these are all Docker concepts. If you know it, you know it. If you don't know it, this is not the video for it. Go to a Docker tutorial and come back here. Any reason to run this in Docker, Harkirat? No real reason. We can actually run it on the host machine as well, because there are problems. There are some security challenges there. You're letting the user change things directly on the file system. They might do scary things. But since the user sort of owns this machine, इस machine पे उसी user का code चल रहा है, doesn't really matter. The other thing is we can protect this our code base from the user. The user won't be able to read our code base because their file system is this Docker file system. They can't really read our Node.js code if code server starts in a Docker container. अगर मैं Docker container में नहीं start करूँगा, if I start it over here, they might be able to navigate to my Node.js code, read my anthropic keys, which is not great. So that's probably a bigger reason to use code server inside Docker than expose it directly on the host machine. ठीक है जी. After it is built, I can run this code server update image that I created locally. And notice the flags. I open port 8080 because if you remember, port 8080 is where we have exposed VS Code. I also exposed port 8081. We'll come to why this is. When you start Expo is also exported on a port. The bundle.js is served from a specific port. That port is not 8080. That port could be anything, but in our case will be 8081. So that's why I've also exposed 8081. And then I've added the volume mount that I was talking about. This -v flag means that the /temp/bolt-worker volume over here is mounted to the /temp/bolt-worker volume on the host machine. And enter. So what this will do is, if I go to localhost:8080, I can see VS Code. How do I change the theme? All right. So now on localhost:8080, in a very unauthenticated manner, which is not great, VS Code is exposed. Is this not what we wanted? What was our initial architecture? Okay, the worker will expose an HTTP server. We have written that HTTP server. It will expose VS Code. We have done both of these things. We have started VS Code on port 8080. We have started HTTP server on port 9091. And both of them are writing to the same file, the same folder in the file system, which is now being controlled both by the user through VS Code and by the LLM through this HTTP layer. So if the user asks to change something, it will talk to the HTTP layer, talk to the LLM will update those files. If the user edits them directly over here, the user will talk to VS Code, update the file system directly through VS Code. Both of them have access to the same folder where the user code is stored. Okay, let me start. This is where I've started VS Code. Currently, if you look at it, it already has some code in here that I was testing with. So let me remove all of this code. Let me go to the /temp/bolty-worker folder. And let me delete this folder completely. rm-r bolty-worker. So that folder becomes empty. Let me re-add it. And this time when I'm adding it, let me initialize a empty expo app inside. Whatever I run npx create expo app at latest in this bolty worker folder. What does that do? If you remember the system prompt, what did we tell Bolt? We told Bolt very explicitly, sorry, the LLM very explicitly, assume you already have a React Native project initialized in the current working directory. You don't need to reinitialize it. It's already present over here. I have used this command to initialize it. So before we start anything, the Bolty worker folder should have a basic React Native Expo project in there. That's what we have told the LLM. We are telling the LLM that tu mat initialize kariyo. It's already initialized. The boilerplate code is initialized. Don't initialize anything yourself. That's what I'm doing when I'm running this command, so that Bolty worker folder, this Bolty worker folder has some basic boilerplate code ready. And iske baad, of course, the LLM will update it. So now that this folder is done, let me rerun the Docker container. When I go to this right now, I see, oh God, the color is white again. All right. I can see a very basic React Native application. I'm not going through the logic of it, but it's very similar to Next.js. It has a layout.tsx. It has an index.tsx, which is similar to page.tsx. This is our first screen that renders. If you ever go to the explore page, then this is the second screen that renders. Read through Expo navigation. I have a React Native video like a few months ago that you can go through, or many videos on the internet. It's a very basic React Native Expo application which uses Expo navigation. And you can decide if you want to use Expo navigation or not, the way you want to run your React Native application. This is their Next.js alternate, where they're getting very close to Next.js with file-based routing, which is why we've also gone with that. Okay. Now, mota everything is done. We have VS Code running. The user can see VS Code in the browser. The user can run commands and whatever, start VS Code, see their application, debug it. In fact, if I run npm run web over here, I can actually see the website on port 8081. As you can see, it says it's running on port 8081. So if I go to localhost :8081, I can see whatever boilerplate code was written over here, rendered on my machine. And this wasn't created by the LLM. This is the command that I initially ran. Only thing is I'm controlling it via a browser. I'm not controlling it via my native file system. If you look at it, this is the very basic default React Native application. Now the question is, how can we ask the LLM to change it? I don't want to edit this myself. I want the HTTP route that I wrote. I repeat, I want, a while back I wrote a HTTP route, this /prompt route. This is the route that the user will hit from this chat window, create a chess application. So I want this HTTP route to update the file system, so that here also I see the new file system, I see all the changes that the user has asked to make. So if I go to Postman, and I was trying this a while back, try to hit the /prompt endpoint. Let me make sure it's running. I don't think the worker is running right now. So apps worker, npm run, bun index.ts. I've started the worker on port 9091. One thing you will notice is I've removed authentication for now because I have not yet connected it to the front end. So there's no user ID over here. And just dump whatever I want directly over here. We should add user ID authentication, yada yada. Let me give it a prompt. For this project ID doesn't really matter over here, but let me give it a project ID. The reason I say it doesn't matter is because every project will have a single worker running. तो उसको मैं जो भी दे दूँ, it doesn't really matter. It's the same project's file system that will be editing. Of course, the project ID will use for authentication checks. कि यार जो बंदा इसको edit करने की कोशिश कर रहा है, the person who's trying to edit the project ID, is this the right user? Do they have the right permissions? So on and so forth. It won't be needed for anything other than that. So let me start the front end and create a fresh project. ठीक है, जल्दी से मैं एक project बना देता हूँ. If you remember, we've already written the backend and the front end. So apps/primary backend npm run whatever bun index.ts. Port 880 is already in use. So let me change the primary backend port to be 9090. Let me send a request to, oh, I'll need authentication here. This won't work. So let me start the front end as well. cd apps/frontend npm run or what? Yeah, npm run dev, bun dev. Yeah. One thing will be I will need to change this endpoint now to 1991 because the backend URL I just changed. Now if I go to localhost colon 3000, I can see a bunch of my, I don't see any existing projects. Why? No, anything in the primary backend logs, nothing right there. Projects returns of 404. Cannot get slash projects. 9090, my bad, wrong endpoint, 9090, refresh. Yeah, I can see my existing projects on the left, and I can create a new project, create a whatever to-do app. What this will do is it will for now just create a project in the database. So if I run this command, it returns me a project ID. Now I need to make the user go to the arena screen, and then I need to make the user send this slash prompt request from the front end with that project ID, with the contents that they wanted, which was create a to-do app. The user will send this, make this API call eventually from the second page. Once they reach the second page, they will know the worker they're supposed to connect to. They will forward this contents over to the worker on that slash prompt endpoint. I'm doing it programmatically, via Postman over here. Eventually it will be done from this front end. Let me also open the logs on the right so you guys can see what is exactly happening. The worker is running. There are no logs on the worker right now. Let me send this request. And notice the first command, the LLM responded us back with this npm install expo slash vector icons, and that failed. Could not open slash private slash temp slash 𝗶𝗫𝗀 workers. Did I change something? Did I add slash private somewhere? I did not. Okay, let's go to what is that file? os.ts slash temp slash 𝗶𝗫𝗀 worker base directory, which will be slash temp. Let's write. Why is it trying to create things in the wrong folder? The wrong folder being slash private slash temp slash 𝗶𝗫𝗀 worker. Running command. So this log came. Running command, whatever the command was. Current working directory is base working directory, which is slash temp slash 𝗶𝗫𝗀 worker. Why is it trying to create it in slash private slash temp slash 𝗶𝗫𝗀 worker? Slash private added to folder. Oh, daisy. Bun spawn adds slash private to CWD. This I'm sure I'm missing something very obvious. Spawn sync. Okay. Doubt this is stored. Don't think that should be a problem. Okay, let's. I don't want to do that. This does exist, and it is at slash temp slash 𝗶𝗫𝗀 worker. That is what I've stored over here. Okay, let's create an index 2.ts. Let's do this. Let's log these three things. Only thing is, I'll replace this with, I don't know, pwd, and let's try to run it. Node index 2.ts. Sorry, bun index 2.ts. Can't find variable base worker directory, so let me add that. V index 2.ts, node index 2.ts. Bun is not defined. Bun is not defined. Oh, bun index 2.tx. My bad. Did return something. V index 2.ts. Not to string. Bun index 2.ts. Looks like the right folder. Why does it have? open that when, okay, let me just console.log commands को भी print कर देते हैं console.log. Let's not print this. Let's do print the base work directory, which I think is right. I don't think there's anything wrong here. So let's try that one more time. Bun index, let me remove index2.ts and cd apps slash, oh, I mean Bolt worker, my bad. Primary backend and Bolt worker bun index.ts. Oh, wrong folder again. cd apps worker bun index.ts. Postman, let's try to send this request again. Fuck, this time it worked. What did I miss the last time? I have no idea. npm install. If someone knows, let me know. Comment me. I'm waiting for your comment. What was wrong the last time? How was the current working directory incorrect? Abhi though it seems to work. Running command this, running command this, running command this, running command this, running a bunch of commands. So installs a bunch of dependencies it needs for you know, a to-do application, and everywhere the working directory looks correct. Running command and then the work directory, that looks good. The hell, it did not create any file. Either the LLM did not respond with that, or the LLM might have responded with that. Okay, let's see. Let's check out the logs. So what is happening right now is the LLM told us to run a bunch of commands. The LLM did not tell us to write any code, or we were not able to parse the LLM response correctly. So let me do a docker run, docker ps docker exec -it, go into the Postgres folder, Postgres, whatever this thing, container, and run psql-u Postgres and select star from prompt. And so the second one only looks like a bunch of shell commands. Yes. I don't see. Oh, no, there you go. It did respond back with the file also. This one right here. Create to-do item.tsx. So why did we not do that? Here is my guess. Pehli baar when we send the request where it wasn't performing correctly, you know, but I don't see an assistant response here. Let's select content from prompt. Let's see. Shell file, bolt action type equal to file, create this file. It's a very long to do item file. Let's keep going. Create another file, which is a very long to do input file. The LLM did respond back with create a few files, but our parser did not create a few files. Create a use to-dos.ts file. Which has, an add to do function, a delete to do function, a toggle to do function, clear complete function, like a hook post probably. Update app button /index.ts. Wait for it. I'm guessing this, I sent this request twice, right? I'm guessing the first time it happened, the second time it didn't happen. That's my guess, but we'll see. Another file, layout.tsx, and I've created a complete file. Included, yeah, that's fine. Okay, the second prompt that I gave me install this, and that also gave me a type file. Why did I not create any files then? Did I remove the log from there? Oh yeah, I did remove the log. Idiot I am. So I had a log over here pehle. I was like, why is that log not coming? Console.log writing to file. वो log नहीं आया तो मुझे लगा command run नहीं हुई है, but actually the command might have ran. In fact, we can check that. Let's go to our VSCode, and indeed we see some problems here. So, but has the code been updated? Do I see to do? Yeah, I do see to do input here. So the files were edited. I just did not see a log. One thing I'm seeing right now is some dependencies don't get installed. For example, React Native Paper, even though I saw it in the logs, it did not get installed. So we should debug that, why that did not happen. Let me do a... Could it be that I'm running npm install one after the other very quickly? So, the first install is cancelled by the second install, probably. npm run web. We'll see. We'll debug this. Probably yes, code does get edited, but a bunch of times some dependencies don't get added. Let's wait for it. Yeah, for example, this dependency also did not get added. So let me add that manually. And the way Bolt does this is a little better. Whenever you open Bolt, they have like a Bolt terminal open on the front end that clearly shows you the commands that are running. That's something we should add as well. Bigly we haven't added that. All right, let's wait for it. Localhost colon 8081. Again, another dependency I did not add. Do these already exist in package.json? They don't. So yeah, somehow the npm install command got interrupted. We'll debug why that is. My guess is because we ran too many things together. And we should make sure we're running them sequentially, only one after the other. That's my guess. All right, let's try that one more time. Another dependency that I had to add manually. I do see some logs still, but the to-do app seems to be working. I can add a task. How do I add a task? Add. I can delete a task. I can mark a task as done. And then I can clear the completed tasks. I can see all the active tasks, the completed tasks, so on and so forth. And the good thing is I can also open this in my mobile app. So there is a scanner over here. It will unfortunately not work because the scanner is pointing to my private IP. That too of the Docker container because we're running this inside Docker. So I will have to manually change this to my, if you can read through this. On my machine, the URL that I've, oh, someone's calling me. The URL that I've typed is, you can probably read through it, 192.168.1.5:8081. That's my machine's IP, followed by port 8081, where we have, exposed this specific bundle. So if I click on connect over here on my this thing phone, you will see the bundle begins to get generated, and in a few minutes hopefully we see the to-do application over here. There is still an error. It expects a fave icon, which I'm assuming is only needed for web. So let me just close web. And seems to be bundling for Android. Wait for it. Oh, 91% done. Still pretty stuck on 91%. I'm hoping this is a warning and not an error. Still waiting. Boy, that took a long time, but I have the to-do application. You guys can't see it, but it's the same application on my phone. If I type something, it throws an error, by the way. If I type something and click on add, it tells me crypto.get random values is not supported. I saw this earlier as well. Okay, whatever random number generation library we're using uses the crypto library, which is having troubles with Android. So what do we do now? We can ask the AI to fix it. We can ask the AI, I am seeing issues with the UUID library on Android. Can you remove it and use a native random function instead? And let me also restart the worker so that you guys can see the logs better. Front end, primary, backend. So I don't have the worker running right now. I do over here. Bun-index.ts. The worker is running now. Let me send this response. So notice, create a to-do application, assistant responded back with this. And then I told it, I'm seeing issues with the UID library, please fix it. It is writing to a file. It uninstalled the dependencies that are not working. It changed 2 files and then it set it done. So now hopefully it should work on Android. If I reload, and try to add a task, this time it worked on my Android machine as well. You guys can't see. But yeah, it did work on my Android machine. Was I not sharing my screen when I was doing all of this? Okay. Only thing I did was I went to the prompt endpoint and I told it, hey, I'm seeing these issues, please fix it. And if you look at the logs from the LLM, it told us to update 2 files. We don't care about the contents. The LLM said, do it, we did it. It uninstalled the bad dependencies. It did not uninstall, it did. It uninstalled UUID. It uninstalls at type/UUID. It changed 2 files and then now it's functioning because it got rid of the library that was giving us problems. And we can do whatever we want from here, For example, one common prompt I like to give it is, this is very ugly. Please style it very nicely. It should look beautiful. Send. And let's look at the logs. It added this gradient dependency, probably because it's a pretty library. It's adding a color.ts file with a bunch of pretty colors. It updated a few components. A lot of them actually. It created a assets folder, updated app.json, got a splash.png, which probably will be, this screen that comes up initially, and done. All right. So let's see, does it look any prettier? Let me go back here. Let me reload localhost colon 8080. Sorry, localhost colon 8081. And now my mobile application hopefully looks a little prettier. Let's wait for it. Where is the terminal? Here it is. Again, npm install is failing for some reason. Even though the LLM tells us to install it, it doesn't get installed. Create an issue, guys, or create a PR. The code is open source. I'm sure you guys are smart enough to figure it out. All right, let's see it again. This time there's another library that I missed. Hopefully not. Let me reload it on my phone as well. All right, this seems like an error. It expects an empty state.png, which we don't have. Let me add assets / what is it expected? I'm going to take a random image and paste it over here as empty-state.png. Oh, seems like we don't really need it. I've still added it. I do see some purple thing over here on my phone. There you go. Can't say it looks very pretty. It has some problems, but they've tried. Let's see. See if it, there you go. So that's what it looks like. As you can see, there's a clear problem over here. and functionally it works. But these two, I'm not a designer, but it seems like these are too close. So is it smart enough to figure this out? The top bar and the navigation tabs are very close. Create some space between them. Send, and let's look at the logs. What does Claude expect us to do? It updates header.tsx. Anything else? Oh, there we go. That fixed. At least on my phone it did. I see some space there. I also see some space here. Very nice. Decent space here. Active, all beautiful. That looks like a decent enough to do application, and all of it was written by AI. And I don't even know what the code looks like, which is great. The best part is going to be hosting this and connecting to it via a website. That's already happening. When I come over here, I see a website that's connecting to a worker, but it's not happening on my main website. What is my main website? This one. That's the last thing that's left. I only have 30 minutes before I leave for some work. But let me connect this front end to the worker backend and navigate the user to the project, let them edit it, chat with it, so on and so forth. Probably going to speed run through this, and in the next section you will see a final working application where everything is working. When you click on the send button, I see VS Code on the right, chat on the left. I can chat the way I was chatting via Postman. I will be able to chat from the browser. So let's get into that in the next section. Alrighty, let's finish it off, guys. Front end जल्दी करेंगे. काफी हद तक बनी गया है. तो I think this was already doing what it's supposed to do. So if I open the front end and search for create a chess app, this is the place. I already had the code to do this. Spons.data.project ID, I think. यही है ना? Let's go back to. That's why I need trpc, guys. Backend/index.ts. It returns a project ID. That's what we get over here. And यहाँ से we need to take the user to the other screen. So I can just do a router.push/projects/project ID. I don't need this. Let's make this a client. It is a client component. Const. Come on, AI, help me here. Const router equal to use router. Why is AI not responding? Is it turned off? It is turned on. There we go. Alrighty. Router.push. So I reach the /project/project ID screen. Let's quickly introduce that. So frontend /app/project/project ID/page.tsx. Export default function project page. Params has project ID. Let's log project ID and see does it work. So if I type something here, click on send, I reach this page with the project ID. Now I need to show a chat bar on the left and VS Code on the right. So before any of that though, I need to hit the server immediately. No, I can send it dhire dhire. So let's do a div class name equal to flex edge screen. That's flex too much. Div chat window and div. This one's going to be an iframe. Source equal to localhost : this would be, where is our VS Code hosted? 8080. Let's replace this with config.ts. Worker URL is localhost : 8080. Let's replace this with worker URL. And one thing I'll add as a to do here. This should come from the router when we add it eventually. So we don't have a router, we don't have a scale level, whatever, we don't have an auto scaling fleet right now. So we just have a single hard coded worker URL. I'll add it over here. And that's it. Let's see. Oh, there we go. Do see two things. So flex, no need for flex goal. That looks good. And class name equal to width by 1/4. This will be width equal to 100%. How do I do this? How do I make its width full? Iframes are always tricky that way. Iframe take full width. Class name equal to w3 by 4. Does that do it? That does it. And same for height. Height equal to 100%. All right, let's add some padding. Class name equal to, or just to the parent class. p-4, p-8, not 98. Yeah, there we go. Decent. Again, scope for improvement, but app bar bhi डाल ही देते हैं. All right, why does the app bar look so ugly? I thought I added padding over here. All right, app bar, chat window, and the thing. And let's do a px-2. That's good enough. py-1. The chat window needs to, well, be a chat window. So full height, h-screen, and flex call and justify between. And then there'll be the chat history up here. And there will be the button that says, yeah, that's fine, I guess. Send. I think it's fine. The only thing is, I move the app bar for now. Cool. So we have a send button. Let's add some padding here. Let's add an input box right before it. So input need to be right next to each other. So div class name equal to flex gap2. That looks good. The chat window is a little hidden, but that's fine. Send button. And what's left? The chat history. So here I need to show the prompt history. So what I can do is I can add another hook called use prompts. Is there a hooks folder somewhere? There isn't. So let me quickly add hooks, use prompts.tsx, export, function use prompts, empty prompt, face prompt, ID content and type, which could be user or system, use state, use effect, await, axios.get, backend URL /prompt, set prompts to be prompts.data. Let's create a new primary backend /index.ts. Let's create a new endpoint called prompts. So app.get prompts auth middleware, where user ID is this and the project ID. So /: project ID. Is this and where project ID is this. That looks good. We should add the user ID check here as well. That's fine. We'll not do it for now. This gives you all of the prompts for the specific user. And let me also keep polling this every 5 seconds. So function get prompts is this. Call get prompts, also do a let interval equal to this thing and return clear interval. Perfect. Project ID should come as an input. Perfect. That should return you all the prompts. So यहाँ पे we will do use prompts. Perfect. Fucking love AI. I do it so fast. At least in pressing tabs. And यहाँ पे I need to chat history is nothing but prompts dot map prompt and just the content of the prompt. That looks decentish. Let's see. Use client where. Yeah, here. All right, that looks good. 6 issues which we're going to ignore for now. And chat history may let me add. Yeah, the only thing that's left is now to send the prompt whenever user clicks on send. And the thing is, We need to, when the user reaches the screen, we need to send their, whatever initial prompt they gave. How do we do that? There are a few ways. We can do it on the screen itself. On the prompt.tsx screen, before you do this, maybe let's also do await. You should get the worker URL here. And then I want to do a await axios.post config.ts worker URL export const worker API URL, which in our case was 1991. Worker API URL slash project slash prompt worker slash index.ts slash prompt. Project ID and prompt is whatever the user has written over here in the input box. Perfect. That should at least start the prompt. Oh god, I'm short on time and I really want to do this. So schema.prisma, let's add another thing. Along with prompts, let's add, actions. For this project, these are the actions that the LLM has done, which could be, create a file, log a file, so on and so forth. So don't need this. Oh, don't need this. This is fine. So project mein jaake actions is action array. Quickly migrate the database. Apps, sorry, sweep package slash db, migrate, added actions, go to os.ts, and yahan pe on file update is whenever it is called, it should be called with the project ID as well, and we should update this in the database. Perfect, that's exactly what we needed. It needs to be this, the contents need to be this. Hold on. Schema, do we have contents in the action? Action has nothing. Content, which is a string. Quickly migrate the database again. Added content. Content is this. Wrote file this thing, or updated file this thing. Let's ignore the type for now. And the same thing is going to happen over here for every command that you run. Say ran command, this thing. That's fine for now. Again, this expects a project ID, which is a string. So now going back to index.ts, it shouldn't be this. It should be file path contents will be file path contents and project ID. Shell command, again, shell command project ID. So rather than calling on file update directly, you get the idea, right? You get what's happening here. I've updated the project ID here. And here, whenever the on-file update function is called, the project ID should be passed so that we can give it to the database. Same thing needs to be happening here. But that will only happen if, the artifact processor doesn't know about the project ID. Either we can add project ID here, or this can call on-file update only with file path and file content. And yahan pe we get the file path and file content, and we call it with file path, file content, and the project. That way, the project ID is also passed over here, so that it fills the actions. Now in our hooks, let me add use actions.tsx. Come on. Yeah, you're smart enough to do this. Export functions use actions should be exactly the same as use prompts. Only thing is, rather than hitting the slash prompts endpoint, the actions endpoint, we need to add that to the primary backend as well. So along with prompts, I need to get the actions. Yahan pe it will be dot actions dot find many action dot find many, and return the actions back to the user on the front end. Yahan pe dot actions, and this will be called, this is use actions.tsx. Yes. So actions and get actions and actions. And one thing that has changed that I saw was wrong is use prompt. We don't need to use prompt.tsx anymore. The actions are what we're worried about. But chalo, if we do want to add this, I'm going to do this. That's fine. And this needs to be dot prompts, because that's what we're giving in the backend. This returns prompts, this returns actions. That's what we get over here. Perfect. That's why you need TRPC, so that you don't need human error in things like these. Thankfully, I'm not human, so it worked. Prompt app bar, where was our page finally? This page right here. So यहाँ पे I'll get the history of prompts. I'll also get the history of actions, and what we're really worried about is actions. What we really use actions. Use action. Come on. There we go. And prompts को render करना कर दो यहाँ पे. But what I really would want to render is, or at least would want to render the actions. But चलो अगर prompts करने में तो सिर्फ user prompts करो. The LLM response is going to be crazy. So let's just filter. Yeah, the user prompts. Render all the user prompts. Render all the actions that are happening. थोड़ा janky है. It should ideally be user prompt, then their actions, and the user prompt, then उस prompt के corresponding actions, so on and so forth. We can fix that. But basically, this is what it looks like. Alrighty. Looks good. Looks good. We have hit the other endpoint as well, which was in prom.tsx. यहाँ पे I'm hitting this first and only then taking the user to the project ID page. So let's do it. Let's try it out. The one thing I'm doing manually right now is ये जो bolty dev folder है हमारा bolty 3d/temp. I'm resetting it manually, but eventually when we auto scale this, then the auto scale server will have a fresh expo app in there. I will not have to do it manually. Abhi I have to do it manually. Create expo app in bolty worker. Fast. All right, I have to call this in 10 minutes, which hopefully should be doable. If everything goes well, then this should work. While this is happening, let me also restart Docker, the VSCode instance. And is this? Let me restart the worker as well, just for kicks. No, not really needed, but chalo kar dete hain. And primary backend. This is. Let's wait for it to finish. Come on. Alrighty. End-to-end test, guys. End-to-end test number 1, which most probably will fail, but let's try it out. Create a to-do application. Let me just open the network log just to make sure everything is on the up and up. Network tab, clear everything, click on send, and a lot of requests went out. Seems like most of them were correct, /projects/prompt, and then did we not send request to get the prompt? prompt. Yeah, we did. It says cannot get because I haven't restarted the server, have I? Let me restart the primary backend because I added a few endpoints in there. Let me refresh. And this time, hopefully, still a problem. Unauthorized because I'm not passing in the headers. Let me quickly do that. ये चीज़ करनी है basically मोटा use prompts. So यहाँ पे introduce the get token hook call, and then come on, you can do it. Yeah, you can do it. There we go. Get token, perfect. Too good, man. AI is amazing. Their UX is amazing at the very least. All right, this is done. Same is going to be true for the other hook, which is use actions. Come on, AI. There we go. Come on, AI. Alrighty. Come on, AI. Yeah, perfect. Cool. Now let's try refresh. Oh, there we go. We see all the actions that are being performed on the left, which include, create a to-do application and everything that happened in lieu of it. Now let me pass it a follow-up this thing. But first, let me try it out. Does it work? Let's see. npm run web. Either is fine, I think. But I'm just going to go to localhost 8081 and see, does it work? It doesn't. Could not resolve add/themed text. Could not resolve this. Component/themed text. Was it created? It was never created. Themed text. I do see it though. Hooks/use theme color. I think the aliases are kicking us in the butt. Babel.config.js. Do I have an alias over here? I don't. So I told it explicitly in the system prompt not to use aliases. Do not use aliases, use relative imports throughout the project, but it didn't do that. It ended up using aliases, for example, in a bunch of places. This is an alias, which honestly shouldn't have been a problem. It didn't introduce an app.tsx. It didn't. So it did the right things. The only thing is it introduced, yeah, there you go. It did add relative paths somewhere. But in other places, it used aliases, which is what is causing a problem. Alias themed text. Babel add aliases. I mean, we'll have to figure this out. React native. Yep. Can't say that is great. Let me close everything. And let me hope if I try the same thing one more time, it doesn't happen. Of course, we need to fix this. Probably an easy way to figure out. We'll just hardcode aliases in our code base. We'll tell the prompt you can use aliases, and then that should work. Let me try it one more time, and hopefully this time it doesn't perform the bad things or doesn't use aliases. So what was my interval in use actions? It was every 1 second. That's good. Okay. So one more time, guys, from the top. Create a, should we go fancy here? Course application. This is my prompt. Oh, I need to do one thing though before any of this happens. Stop the worker. I need to clear that folder of ours. So let me again go to delete the bolty worker, re-add the basic expo app in here, and then try again. Sudo rm-r bolty worker, expo app at latest, bolty worker. A lot of this has been put together abhi ke liye. And if when we're polishing this application, which we will, the prompts will change a lot. The base expo app will change a lot to avoid these errors. Because if a user comes and they see this random, they're like, screw it, I'm not going to do it. So what are those problems? I'll list them down in a README. So you should look at them and set up the project locally and try to fix them. One of them is npm install doesn't work sometimes. One of them is aliases causes issues. Another one is we haven't added auto scaling. So there's a lot of things that need to be added / fixed before this can be deployed to production. I don't want to make a follow-up video. I'll just code and I'll see you on GitHub if you want to contribute and do this as well. We did the same for Photo AI. I built one version and then a few people contributed to the main version of Photo AI. It looks decent now. Go to photo.100steps.com to try it out. And same thing we'll do for this guy. All right. So the boilerplate is done. Primary backend is up. Frontend is up. Worker is up. Let's try it one more time. Go to localhost 3000, give it a prompt, create a gym tracking app, let's say. I'm just giving it more complicated prompts, which is something I probably shouldn't do right now, but I will still do it. Oh, one very big problem. I did not restart VSCode, so it'll, be a little janky right now. So let me stop it again, restart it, go back to the home screen and quickly delete the bolty worker again. Where is it? There it is. Create expo app again. I should have just copied this to a different folder to make this a little easier, but chalo. Create expo app. Bolty, I totally forgot. What is the name? Worker. Bolty-dev. What was the name of the folder? Bolty worker only. So worker. While this is happening, I need to restart VS Code. All of this will not be a problem when we have an auto scaling fleet because every user will get its independent server. It's a problem right now because the same machine is being reused by every project. Cool. Restart. That seems to work. Create a, what do you want, guys? Course app is a little course view app, let's say. Trying to keep it as lean as possible to see at least one working version. All right. Have a basic project over here. Hopefully the LLM is responding. Unless I shut it down and I forgot to turn it on. No, I did turn it on. So the LLM is responding with a few commands. I don't see those commands on the front end, which is not good. Is the actions endpoint being hit every 1 second? It is. Oh, there you go. Okay. So updated file /index.tsx. That's the first thing that happened. What about these commands that ran, bro? I don't see them on the front end. I see all the file updates. I don't see the running commands. I probably missed something obvious. But yeah, let's wait for this to finish and then proceed from there. Let me go back to os.ts. What did I miss here? Prisma does not create project ID and content ran. This thing that looks right. Project ID, content. This is probably failing. I don't know. Why would this DB call not happen? Is it because I did not await it? I don't think that should be a problem. Yeah, all the update commands are coming, which is great. What is not coming is the other thing. One thing I'll do is I'll go to worker index.ts and add another thing here. Await Prisma client.actions.create contents done, so that I have a final done that appears over here. I know the LLM did what it was supposed to do. Okay, create, that's fine. The only thing question is, again, why is this not happening? And I don't think an await is what's causing it, but who am I? Let's add an async over, like an await over here, so that this ran command also comes on the front end. Let's try it one more time. Localhost 3000. Clean the Bolty worker server. rm and what else? Create expo, restart the Docker container, and restart the worker. Not really needed, but let's do it just to keep things clean. Restart the worker as well. Create a to-do application, basic one. All right. Boilerplate is done. Just for kicks, restarting Docker one more time. Alrighty, folks. I would say this is the moment of truth, because 2:39, 2:45 is when I have to leave in 5 minutes. Send request. Alrighty. Create a to-do application, basic one is the prompt that I gave. And now I'm waiting. And Bolty worker is empty, which is not great. Alrighty. What have I missed? It indeed is empty. So I missed something obvious. Let's go back here and stop the worker. Let's go back here and run create expo app. Did I give it the wrong folder name or something? Probably that's what I did. Let's fix that. Bolty dash worker. Restart Docker. Restart this. Not really needed, but फिर भी worker. Alrighty. Create a to-do app. Come on, boy. You can do it. Send. Alright, see some code. See the command being run. That's beautiful. cd into this folder. Run npm install. Run npm install. Run npm install. Update a file. Update another file. Update another file. Beautiful. I like it. Update another file. Update hooks/use todos.ts. Updated file app/index.ts. app/layout.tx. Ran npx expo start. I am unsure if this command is running either. I think all of them are not running. But the file system hopefully is updated. So npm run web to run this application on the web. This will of course not happen in the real world. Okay, a tab opens. I'm running it locally, so it's happening. All right, moment of truth. I'm sure some dependencies are not installed. Yeah, React Native paper. So npm install. Basically, all of these dependencies that have been added. Most probably these npm commands are not executing as expected. So let me run them. npm install React Native async storage. Oh, oopsie daisy, at react dash native dash async dash storage slash async dash storage. npm install react dash native dash paper. I think what's happening is the last command succeeds, but ऊपर वाली दोनों cancel हो जाती हैं from the third command. That's my guess. I could be wrong, and if I am wrong, tell me. npm run web. Yeah, I think whenever the LLM tells you to run a bunch of commands, you should run them sequentially and not parallelly. I think we end up running them parallelly, which is what causes this install and this install to fail, but the last one still works. Alrighty, bundled for the web, everything looks fine. If I refresh over here, the to-do application is working. If I add something, it does get added. Everything is cool. Follow-up questions. Does this input box work now? Let's go back to cursor. Let's go to input box, which will be in page.tsx, this one. We have an input box. Does it do anything right now? It does nothing. So button on click equal to axios.post prompt project ID and prompt, and we'll come to what the prompt is, but axios add prompt as a state variable const prompt comma set prompt equal to use state, and whenever the input changes, that's this thing right here, on change equal to set prompt. Alrighty, let's try a follow prompt now. Let me add some padding to the input box so we don't see this. PB-28. All right, let me add a follow-up thingy. Kiar, you are great. You look like this. You don't look very pretty. This doesn't look very pretty. Please make it prettier. Send. Nothing happened. Worker URL, which is incorrect. Worker API URL. And one thing is I kept this unauthenticated, but eventually should be authenticated. So headers, authorization token, const token will await get token, and यहाँ पे get token will use auth imported from Clerk, worker API URL imported from config. Alrighty, try it again. This doesn't look very pretty. Please fix it. Send. Oh, there you go. Seems like it didn't fail. Ran command npm install react. Oh, of course. The thing came over here and not at the bottom. We need to fix that. But seems like it's working. Ran React Native vector icons for some pretty icons. React Native paper. I thought we already had that. I thought we had this, but maybe a better version. Updated a bunch of colors, to-do items, to-do import, to-do list. AI is doing its thing and, prettifying whatever we want. Updated components / filter chips.tsx. And as you can see, it tells the colors doesn't exist. That's because the LLM probably hasn't. Oh, it has added that. Constant / colors from, I don't know, maybe if I reload it works. Updated app / index.tsx. Ran command expo start. So done. The follow-up is hopefully done, but there is a problem. The problem being, say my colors.ts doesn't exist. So colors.ts, it does exist, but I think it's constants / colors. Colors.ts, yeah. All right, that looks wrong because it needs to be capital colors. Yeah, so AI hallucinated, guys. Let me replace this everywhere. Command Shift H. Constant / colors should be replaced with constant / capital C colors. And now rebuild. Still the same error. Did I not execute these? Oh yeah, replace, reload. bunch of more debugging. 2:47, I am late. Alrighty, wait for it. Nope, bunch of errors. That does work though, but again, a bunch of errors in the console. All right, it does look like a prettier version of the to-do application. And yeah, seems like it's doing what it's supposed to do. Active, completed, all. Let me add another follow-up prompt. Okay, change the colors to be black. You can't see it, but that's what I've written. Change the colors to be black. I don't want it to be blue. I want it to be black. The prompt will appear over here for now. Change the colors to be black, and then actions will get appended over here. Updated file constant/index whatever color.ts. Updated file components/todo-item.tsx. Updated file components/todo-input.tsx. Updated file components/todo-list.tsx. I think the problem remains the same. It's importing, /colors and not colors. So that might be one thing I have to manually change. Let's wait for it to finish, then I'll do it. Task statistics. Updated app/index.tsx. I think that's the last one. Or layout, and then it started. Alrighty. So again, I need to make this replacement everywhere. There's another big thing we have missed for Sabita, but we'll get there when we get there. There you go though. The colors have changed. Everything looks fine. Perfect. Same thing will work on my mobile application. If I quickly try to show you, does this work on my mobile app? Let's see. Expo. Actually, I just need to reload. It's the same URL. So reload. All right, let's go to Expo again. Connect. Oh, I think the same problem will come. Okay, crypto will be a problem, and then we'll have to do a random number generator. So we'll get there when we get there. Building and oh, there you go. I see the to-do application. Surprising. I thought it'll fail. It'll probably fail when I try to add the to-do. But yeah, the to-do application now appears on my phone as well. But if I try to add something, I think it'll be a problem. Yeah, because crypto doesn't exist. The same crypto problem. Again, I can ask the AI to fix it. So AI, don't use UUID. It is causing issues. Please use some native random number generator. Send. Alrighty. Let's see if that works. Let's see if the actions are getting updated. Ran command uninstall UUID. Updated file generateid.ts. I created a new file called generateid. Updated the hook, and that's done. Let's try to reload. And hopefully this time the to-do application works. Wait, wasn't sharing my screen. But long story short, I just gave it another prompt. I said, don't use UUIDs. It is causing issues. Please use some native random number generator. And the command that it ran in return was it uninstalled UUID, generated a bunch of files, and then ran an expo start again. Now, again, I have the application running on my mobile application or mobile phone. But when I try to create a to-do this time, go to movie or they will kill you. They, as in the people outside who will kill me because I'm late for the movie. It does work. I see the to-do over here. I can mark it as done. When I do, the progress bar at the top increases, so on and so forth, right? Cool. A to-do application that you can create via a website. Looks fairly ugly right now. Oh, you guys can't see the screen, can you? Looks very ugly right now. A lot of things to change. I am writing a very big README of things to update. I'm going to update them anyways myself. But if you're in Super 30 cohort otherwise, feel free to pick them up if you want to directly work with me. Super 30 people just ping me. A lot of things to do here. Let me quickly recap them. Hopefully demo is clear and you sab samajh aa raha hai ki haan, theek hai, I have a landing page where I can see a history of my old projects. Let's wait for it to open. I can see a history of my old projects. These are the ones that I created today. And create a to-do application is probably the last one that we just created. If I click on it, I can see the history of things that were done to create it. I can see the VSCode instance on the right. I can interact with it manually from here, or I can ask the AI to fix things. There are a few things that are missing here. I'm going to talk through them and write a README for it. The things that you need to do if you want to take this as a challenge, set the project up locally. That's the first thing. And then readme.md things to do. Number one, complete the orchestrator. It's an empty folder right now. Architecture is discussed in the beginning. It should talk to ASGs and scale them up / drain them when a worker becomes idle. That's one. Send the user response back to the LLM. If a user is changing a file, the LLM needs to be aware of this. For example, वो colors और taste मैंने update किया था, LLM को वो पता होना चाहिए, so that in the future the LLM performs correctly. It should know the changes that I have made. So in the responses that we're sending it, one of the other responses is going to be I have changed something. We are not yet forwarding that to the LLM. What else? UI cleanups for sure. Right. Orchestrator, router are the same thing. So you have to do them together. What else? There are a bunch of other things. Figure out why npm install doesn't work from time to time. Most probably we need to run them sequentially. So create some sort of async queue to do it. I think that's it. I might be missing something. You'll find all of this on GitHub. Let me quickly create _100x / let's call this one mobile magic and publish it. Hoping there are git ignores that make sure I don't commit my envs. Git remote add origin, copy paste, push. Alrighty, the code is present on _100x / mobile magic. These are the things to do. Figure them out. I'll add bounties for the difficult ones, easy ones as well. But like difficult ones, अगर तुमने ये figure out कर लिया, there's a lot of load off of me, so that would be great. This also, this probably leave it to me because I want to structure it the way I want to. UI cleanups great, landing page nahi hai, things like these, and well, I guess Bolt doesn't have a landing page, so we don't really need it. But figure out, yeah, this one is also a good one to do, and probably what I've written here is right, but I could be wrong, so figure that out. Cool, Haji. Hopefully it was an interesting video. Code is out there, and all the code gets updated. My last video was Photo AI, and if you look at Photo AI, since then it's changed a lot, and 73 commits. The first commit was mine, everything else was people fixing it. So feel free to go through any of these repositories. If you are looking to join the next Super 30 for free, then this will be one of the places that we look at. A very easy proof of work, right? So that might be another reason to do it. Bounties is another reason to do it. Just trying your skills out, another thing to do it. So hope to see you on GitHub. I don't think I'll create a follow-up video fixing this, but this will be fixed directly on GitHub. It's very hard to explain. Although I want to create a video on ASGs, we'll see. So I don't know if there will be a follow-up video. And I think there is one thing I discussed in the architecture initially, which I haven't covered, which is the worker, this thing right here, the worker orchestrator and Redis. So we need this. We need this to scale up the servers. We need the server to tell whenever it's done, it's idle, to tell the orchestrator to bring it down. This is something we need to figure out. Very interesting and very simple. I've done this in the past for some other company. So try to do this. You need an AWS account for it though. So that might be a blocker. Cool. With that, we'll call it. Thank you for joining. Let me know how the video was. I'll see you guys in the next one. Bye bye.